It's going to be a mildly hard class. It will be very actionable. Two-way, you guys will have to code. I'll code eventually, but try to code it first yourself. Everything that we are doing, we have already done. So let's see how many of you are able to, code everything yourself. And if that happens, then that's great. If that doesn't happen, we will still have to, move on after this to Ethereum or, whatever the second part of Web3 that includes whatever Solidity, Rust, and smart contracts. But I'm hopeful that some of you are able to create this. There are some small challenges that will come here. I've put hints in the slides that I've pasted. So whenever you go through those challenges, try to go through the hints, but generally try to code yourself. Next week, recap everything from now. No, I'll just create an offline video for it. I don't think we need another week for, everything we have done. We've gone fairly slow, I think. So let me recap right now only what all we have done until now. Let me pin myself. There we go. The audio is a little bad because I do have my mic, but my wire broke. So I can't do much without the mic. So I'll have to talk like this. I'm sorry, I'll try to be a little bit louder. To recap what I was talking about, we're starting today's class. We have, did I share the right thing? Maybe not. These are the slides for today. I think I shared the right thing. Yep. To recap, this was the first part of Web3, intro to blockchains, cryptography, gas, native tokens, transactions, instructions, airdropping. Hopefully this was simple enough, took us 2 to 3 weeks to do it, less than a month for sure. Then we moved on to Solana. There is one thing that is pending in Solana, NFTs, attaching metadata to NFTs and Metaplex. How many of you heard what happened to Metaplex yesterday? Probably not a lot of you. I'll talk a bit about it. It's pretty interesting what they used to do, they sort of do right now as well, and how they've been able to make 150 to 100 mil they might make based on one very shady thing that they have done. So this is one thing that is pending, will most probably come in an offline video. Everything else that's mentioned here, ETH we probably spent 2 to 3 weeks on. Solana we spent majority, I would say 3 to 4 weeks. And some of these projects we've built during the classes, so I'm not going to repeat them. That's the client-side wallet in JavaScript and creating a token and transfer program on Solana. All of this is very intertwined. All of the projects that we're building, if you know one, it's very easy to build the second one. Today, what we're building is slightly difficult. It will require you to, understand some small flags that you need to make this work. So we'll understand that. We'll be making a cloud wallet in Node.js. And if you can build this, you have sort of built the backend of BonkBot. Front end, of course, you need to build in Telegram. So we'll discuss 2 different approaches to build this. What might be better for an application like TipLink? What might be better for an application like BonkBot? And what is the difference between these applications? Why would you go with one approach over the other if you are building BonkBot versus if you're building a cloud wallet? This is what we're doing today. What I was talking about here was Metaplex. Let me give you a brief about this. Then I'll give you a brief about the problem statement of what we're building today. Then we'll go through BonkBot a bit. Then we'll try to build the backend. Okay? Without any further ado, let's start off by understanding the project for today. What we're building is something called BonkBot. Specifically, we'll build the backend. I'm happy to do a video on front end also. That would involve going through some Telegram APIs. How do you build a UI on Telegram? Probably a good video to do as well. So we can try building the UI today as well. But the backend we will definitely complete. What is BonkBot? BonkBot is a Telegram based trading bot. I don't know how many of you guys do this, but a lot of people do. They trade on Telegram. Harkirat, why? Many reasons. People don't want to deal with private keys. If they want to buy some specific meme coins, they have to go to Telegram. And the last reason that they do this is because these Telegram bots give you some alpha from time to time. They have the quickest response time whenever a token is launched. So अगर आपको speculate करके पैसा बनाना है, तो a lot of people spend their time here. To quickly show you, this is how much BonkBot has made in the last 1 year. And there are a bunch of other bots that came up. They're also doing pretty well. What's that one called? I'm forgetting the name now. So I forgot the name. I'll find out and let you know. But this is how much BonkBot has made annualized. That's $240 million. The graph isn't working right now. Their daily revenue is like $500,000. They make this much money in trading fees. We'll understand what that is. How do you make that sort of money? But it's a good business on Solana, a good project that everyone is trying to build. If there's this, never mind. Long story short, good project to build and understand client-side Solana, because this would not require you writing a smart contract just yet. Question is, how do you build it? How do you build an application like BonkBot? Let's just see what BonkBot looks like actually. I have it installed. I'll have to open my Telegram, which I was a little cautious to do until now. But let me do it. This is what BonkBot looks like. For me, it is showing a lot of things. If you go to BonkBot, it will redirect you to Telegram. You start talking to this bot. You don't need Phantom. You don't need Backpack. You don't need private keys. You don't need anything. They will do all private key management for you, all of these things. You just have to talk to it and ask it to trade. So if you visit it for the first time, you will send it a start command and it will create a Solana wallet for you. What is it doing? BonkBot is creating a Solana wallet for you. What does that mean? That means that if this is the backend server of BonkBot, this is the database of BonkBot, and this is their front end. What is their front end in this case? It is a Telegram bot. Could it be a website? It could totally be a website as well, but they have taken the approach of Telegram and been fairly successful at it. What do you do when you sign up over here? When you go to this bot, you talk to it. You ask it to create a wallet for you. You send it a bot command called start. What does it do? It tells the backend, okay, hey, this phone number 70111, whatever this number is, wants to create a new wallet. So what will it do? Here, it will create a new private key. It will create a new public key and store it somewhere. Let's assume it just stores the private key over here in that database, plain text for now. We'll later understand what are the better ways to do private key management. But अभी के लिए assume करो कि if you send it a start, इसने database में एक private key डाल दी, हरकीरत को assign कर दी. So the database looks like this. Here there is a user with ID 1, their phone number is this, and this is their private key. इनके database में पड़ी है ये. Now, what does this response give me back? It gives me back my public key. कि यार हमने तुम्हारा wallet बना दिया. We have made your wallet somewhere. Do whatever you want to do with it. And then you can talk to it to do things like, I want to transfer Solana. I want to buy some meme coin. I want to eject out of it. What does ejecting mean? कि यार मुझे मेरी private key दे दो. I don't want to use you anymore. I will go to Phantom and do it. So you can also ask for this private key back. Most people don't. Most people don't want to deal with private key management. But 99% of the people will just be over here and trade by talking to the bot. It felt like a very futuristic idea in some hackathons, but ended up picking up a lot of wind. Why? Because a lot of people on Ethereum had a lot of Ethereum whales were present on ETH, did not know how to buy Sol, did not know what Phantom was. So a lot of them flocked to Telegram because a lot of meme coins were growing. And in a single, message, they could buy Solana, hold Solana, buy a meme coin. So a lot of these wealthy people came here. That's why, this became very popular. How does it make money? Can you guess? If this is the backend and this is the front end, I am asking it to create a wallet. It will not charge me money over here. It will give me a public key. I can transfer some Solana to this public key. I can totally transfer some Solana to this public key. Let's say I have 1 Sol now in this wallet. Now, whenever I am buying a meme coin, let's say Doge or whatever random meme coin, if I give it 1 Sol, I was supposed to get back, let's say, 200 Dogecoin. I get only 99% of that. They take 1% trading fee, which is really high. If you go to any decentralized exchange, if you go to any centralized exchange like Binance, you don't pay as much money. You pay like 0.1%. For most exchanges, it's 0.085% that you pay. Why are these whales so dumb to use Telegram? Because they are. Unko convenient hai. They are okay paying 1% fee. So why are people using it? For convenience. How do they make money? Through trading fee. How much is the trading fee usually on a normal exchange? If you want to convert US dollars to this Dogecoin, you give 0.085% to a normal exchange. To these guys, you give whatever, 1% as trading fee. That is what we're trying to build today. Can you guess what the front end backend would look like? If this is the backend, what does it need to support? It needs to support 4 endpoints, mota. One, the user signs up. User signs in. You don't even need this website, but chalo, let's assume that it is a simple website for now. It is not BonkBot, but if it was BonkBot, तो sign in करने की कोई जरूरत नहीं है. With every request, you can just गेट द यूजर्स फोन नंबर फ्रॉम द टेलीग्राम बॉट एंड आप बस उसका फोन नंबर यहाँ भेज दोगे. द वे वी आर डूइंग इट, we will assume this is a website where the user is coming, let's say. But if you are building bonk bot in actuality, तो उसकी तो जब भी आप उससे बात कर रहे हो, it will talk to a bot server. The bot server will know कि अच्छा this तो is this number, and it will talk to the backend and tell कि यार इस नंबर के लिए ये ट्रांजैक्शन कर दो. तो the challenging bit here is simulating transactions over here. यूजर का वॉलेट आपके पास है. यूजर is going to tell you and give you random things. I want to buy a meme coin. Let's say you support buying NFTs as well. I want to buy an NFT. These are random transactions that the user can give you. You need to support these transactions. You need to sign these transactions, send them to the RPC, let the user know, okay, hey, your transaction has been done or not been done. So we'll be building a backend, standard Node.js. We should create a database where we'll be storing, let's say, the private key for now. We have to create a front end. Let's say we create a website for now. Eventually we can change it to whatever we want, like a Telegram interface, a mobile app, doesn't matter. The point is that the user logs in with something, phone number, username, password, and their wallet is managed over here. How do you think this can be done? There are two ways to do this. I was talking about two approaches. So let me explain both the approaches and the pros and cons of both the approaches. Then we'll code one of the approaches, which is slightly harder. Then we'll code the other approach. Okay? Hopefully the architecture is simple enough, nothing too complicated. Until now, we have done this. KR, if this is the browser, and this is Phantom, we have created websites that can send tokens. We have created websites that can swap tokens. But we ask Phantom to sign a transaction. Today what we're building is, we are going to create a website which doesn't have any Solana wallet adapter. It just has functionality, sends an HTTP request to a backend, which needs to sign the transaction and then send the signed transaction over to the blockchain. The private key is stored somewhere here in the database. The user is just telling you what to do. You are doing it on their behalf. That does not happen in Phantom. Phantom, you have your private key. Here you will not even know your private key. It will be stored somewhere else. If you want, you can eject out the private key. What are the challenges here? What is the most difficult bit here? What is the most challenging bit? What will you be grilled on in an interview? The people who have made this, उनको interview में क्या पूछा जाता है? What is the most common question here that will be asked? Can anyone tell me in chat? Storing private keys, perfect. Private key management. The most difficult bit here is how do you do private key management? And believe it or not, most of these bots have very bad private key management. Let's talk about it for 5 minutes. How do you do private key management for a bot like this? You are not creating a centralized exchange. For those of you who know, सेंट्रलाइज्ड एक्सचेंज में देयर इज अ सिंगल वॉलेट जहां सब यूजर्स के फंड्स होते हैं. देयर इज अ सिंगल वॉलेट वेयर यू स्टोर ऑल यूजर फंड्स. सो इन अ सेंट्रलाइज्ड एक्सचेंज दिस इज अ स्लाइटली इजियर प्रॉब्लम टू सॉल्व. इन अ डिसेंट्रलाइज्ड एक्सचेंज देयर इज नो private key management that you have to do. User owns their private key. This is a third category. A category where you can't store all the user funds in a single wallet. Every user has their own wallet. उनकी private key आपको manage करनी है. How would you do it? Ugly approach 1. You store it in a database. User ID 1 has this phone number, username, and this is their private key. What is the downfall here? If the database gets hacked, all of your users are screwed. उनका सारा पैसा, उनकी सारी प्राइवेट की पब्लिक हो गई. People can do whatever they want. This is not what most of these wallets do. Of course, they have one level of encryption. So what they do, what most of them do is, okay, in their backends, they have basically hashed the data over here. यहाँ पे जाने से पहले the key gets hashed somehow, not hashed, sorry, encrypted. The key is encrypted before it is stored over here. There is some master password that you can use to unlock the key. That is one other ugly approach. Okay, this is your backend. This is your database. Before storing the private key, it has been encrypted. So an encrypted private key cannot, do much, or you can't do much with. In an encrypted private key, even if the database gets hacked, nothing goes wrong. But if your backend gets hacked and your database gets hacked, then of course you are screwed now. आपकी private key यहाँ stored है, मान लो in an environment variable, not your private key. Your secret to encrypt the private key. Your क्या हो रहा है? This is the backend. This is the database. User says I want to sign up. We generate a private key over here, PVT. But before we put it over here, we encrypt it using a key some master key we use, some encryption algorithm we use, doesn't matter which one. And the final thing that is stored over here is some random gibberish. It is not this private key, it is some random gibberish. What is the problem? अगर ये और ये दोनों hack हो गए, then you are screwed. What can be a slightly more better approach? I was thinking multi-sigs, but multi-sigs cannot be used here. A multi-sig is as the name suggests, a wallet that needs to be signed by multiple private keys. तो आप चलो ये एक idea आ गया मेरे को, even though this is a weird idea. You can have multiple databases. Database 1, database 2, database 3. यहाँ पे you can store, let's say, let me give you a smaller example. Let's say the private key of the user is this 1 2 3 4 5 6 7 8 9. Let's say कि user की private key ये है, तो one approach you might think of कि यार मैं 1 2 3 यहाँ store कर लूँगा. I will store some part of the private key over here. Some part over here. One, two, three over here. I will store 4, 5, 6 over here. I will store 7, 8, 9 over here. Is this bad? Can I do this? Can I break the private key into 3 parts? ये part 1, ये part 2, ये part 3. Does it make me extremely safer compared to storing it in a single database? You might say yes हरकिरत, क्योंकि अगर एक database hack हुआ then you will lose money. अब user को 3 database hack करने पड़ेंगे. User will have to hack your DigitalOcean database. Let's say that's the first place where you have deployed it, your AWS database and your GCP database. Let's say you divided the private key into 3 parts, 3 अलग जगह store कर दी. But still, this is still your central point of attack. अगर यहाँ पे किसी ने attack कर दिया, then you know they have the credentials with all 3 of the database. They will screw you over. यहाँ से first part आ जाएगा, second part आ जाएगा, third part आ जाएगा. Is there another problem in this approach? Is there another problem in breaking a private key into 3 parts? 1, 2, 3, 4, 5, 6, 7, 8, 9. Is there another problem in breaking a private key into 3 different parts? That makes it less secure than something else that is very similar. Private key को break करना is not a bad option or not a bad thing. But is there a better approach? Or what is the downside of this approach? Storing private keys. Anyone in chat? Oh. Some good ideas actually. What if database goes down? You have to make sure 3 databases are decent. Hassle, a lot of hassle to track 3 different databases. Sequence, efficiency. Company सारे लोगों की private key लेके भाग गई तो this तो you can't fix वैसे. In a centralized entity, you can never fix this. Okay, a bunch of answers, not the right answer. The right answer is, okay, even if they hack 2 of them, right? What makes a private key extremely secure is that it is 32 bytes, it is 64 bytes, it is 128 bytes, it is unguessable. अगर उनके पास 2 shards आ गए ना, 1, 2, 3, 4, 5, 6, तो it is easy to iterate over the last set of strings and brute force the pass private key. तो आपको लग रहा है कि आपने 3 जगह ब्रेक कर दिया, अगर 2 भी हैक हो गए, you are screwed. Even if 2 of them are hacked, the 3rd shard can actually be brute forced. You can't just break a private key into 3 parts and hope कि भाई security is now तीनों की तीनों चाहिए होंगे. They only need 2. बाकी का वो brute force कर लेंगे. You can't brute force this, but you can brute force this much. इतना तो brute force कर दोगे. If this private key is, let's say, 32 bits long, मान लो पूरे के लिए you need 10 raised to power 8 iterations, which let's say is a very big number. 10 raised to power 8 isn't, but let's say it's a very big number. Last के लिए कितना चाहिए? Only 1000 भाई. How easy is it to do 1000 iterations compared to 10 raised to power 9 iterations? Much easier. So the effort isn't 1/3. Effort is exponentially lesser. If you have to guess this part, अगर आप थोड़ी math लगाओ तो if let's say this is bytes, this can be 0 and 1, this can be 0 and 1. What are the total possibilities? 2 raised to the power 9, which is a decently big number, still can be brute forced. But compared to 2 raised to the power 3, it's exponentially bigger. This is exponentially bigger. This isn't 2 raised to the power 3 compared to 3 into 2 raised to the power 3. वो 3 गुना बड़ा नहीं है. It is 2 raised to the power 9, 6 times bigger. So if you break the private key into 3 parts, it will not work. दो भी database गए, you are screwed. So what can be the better approach here? Does anyone know the answer to this? कि how do you break private keys, which is the second best approach to doing something like this? How can you break private keys in production? Oh, no one's heard of Shamir's. IndexDB's database, browser, Summon, powerful storage, encrypt. Okay, few people know Shamir's, I don't know now or later. But yes, the answer is, I don't know how you pronounce it, Shamir or Samir Secrets. Salting is not a solution over here. Why would salting ever? That's not a problem only, but no. It is that there is a better algorithm called Shamir Secrets. I think it is SHAMIR, but it could be SAMIR as well. Shamir Secrets is an algorithm, not just true for private keys, but a bunch of things. There's a very nice video I'll happy to share after the class. If you ever want to, if there's a very long string, 1, 2, 3, 4, 5, 6, 7, 8, 9, and you want to sort of encrypt it such that कि यार मैं इसके 5 हिस्से करूँगा. I am going to do 5 parts of it. Let's say the first part looks like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's say this is how I broke up my private key into 5 parts. Shamir Secrets इतना plain text में convert नहीं करेगा उसे कि हाँ भाई मैं ये ले लेता हूँ and यहाँ डाल देता हूँ. I will take this and put it over here. It does not do that. What do Shamirs do then? They break it into 5 parts, but not so obviously. कुछ random निकलेगा उसमें से, मतलब it is encrypted, decrypted, hashed some way, such that the final thing is gibberish. You can't guess anything with just one shard. You can't guess anything with just 2 shards. अगर मैं आपको ये दोनों दे दूँ, तो it's not like your probability of guessing this became easier. If you break it using Shamir's, the algorithm itself, the way it is written, it will make sure कि difficulty तो उतनी ही है भाई. Now you still have to brute force. Even if you got this and this, you can't get back the private key. What you can do is, not even forget that. What you need is कि आपको 500 के 500 चाहिए. You need all 5 of these. Only then you can recreate the key. And given कि आपको 4 मिल गए हैं, you got back 4. Your probability of guessing the last one does not increase. ऐसा नहीं है कि if you got 4 of these secrets, now you are exponentially easier for you to break the private key. The difficulty remains the same. It breaks it into some parts, but it breaks it such कि उसकी difficulty to deduce it does not go down if you can get your hands on some of these parts. तो Shamir looks like the great approach कि हम तो Shamir secret use करेंगे हर कीरत. What will they do? Take a private key, break it into 4 parts or 5 parts. And now if you want to ever recreate the private key, you need all 5 parts. But what is the problem here? Some people mentioned a while back, whatever database goes down Harkirat, there is a lot of redundancy, there's a lot of requests that you have to send. आपको 5 database से connect करना पड़ेगा. Yes, which is why Shamir's has this concept of thresholds. यार आप break करो 5 parts में, that is fine. Break your private key into 5 parts. But you can create a 3x5 Shamir. You can create a 4x5 Shamir. What does that mean? That means कि अगर 3 भी इनमें से comply कर गए, if you find 3 of them, आपकी private key recreate हो जाएगी. It can be these 3, it can be these 3, it can be these 3. Doesn't matter. Any 3 can recreate the original string. तो अगर ये down है for whatever reason, if this is down for whatever reason, then you can still recreate the original private key. But if someone gets their hand on 1, or if someone gets their hand on 2, their probability of decoding the private key does not increase any further. So what is the second best approach here? Maybe multi-sig is the third best approach. Bunch of approaches we discussed. The dumbest approach is store it in plain text. The hell. Dumbest is store it in plain text. Slightly better is encrypt before putting it in there. Third best is shard the key in a dumb way. Third best actually is a multi-sig. Actually, shard is the third best. because all three of these are very unsafe. You should not do it. In fact, but most of the bots that you see do this. They don't do any extra level of encryption. They just hope, हाँ भाई ठीक है, database will be secure hopefully. Then there is what we discuss next. There is encryption sharding. There is there is multi-sigs. Multi-sigs will not work for us. Multi-sig होते क्या है कि 2-3 अलग अलग प्राइवेट की मिलके साइन करेंगी. 2-3 private keys you need to sign a transaction for a user. Problem here is we are building BonkBot. हमारे यूजर के पास एक ही एड्रेस है. Our user has a single address. We want to allow the user to eject out eventually. Eventually किसी दिन वो हमसे हमारी प्राइवेट की भी मांग सकता है. If I show you BonkBot here, if I show you BonkBot, there is a button to click on wallet, and oops daisy, I don't know what I did, but there is a button to export private key. There is a button to export private. User अपनी प्राइवेट की वापस मांग सकता है. तो अगर उन्होंने अपनी प्राइवेट की वापस मांग ली, कैसे दोगे? if you have created a multi-sig, if there are 3 different random wallets, signing a transaction on the behalf of the main wallet, ये मेरा main wallet है, पर इस पे पावर ही नहीं है साइन करने की एसेट्स पे. एसेट्स आर समवेयर एल्स, कंट्रोल्ड बाय मल्टी-सिग. दैट इज अ प्रॉब्लम. हमारा यूजर तो किसी दिन प्राइवेट की मांगेगा, उस प्राइवेट की से कुछ कर ही नहीं पाएगा. Our user will not be able to do anything with this private key if you are controlling their funds via a multi-sig. So even though you can use a multi-sig, it will not work for this specific use case. Works for some organizations. WazirX, for example, was using a multi-sig. A lot of exchanges used to use a multi-sig. They don't anymore. But one more approach is multi-sigs. Then comes the Shamir secret support approach, which is slightly better, as you can tell कि हाँ ठीक है भाई, अलग अलग जगह प्राइवेट की हैं. दे ऑल डोंट टॉक टू ईच अदर, एंड देयर इज अ सिंगल थिंग दैट एग्रीगेट्स दोज व्हेनेवर नीडेड. ये अगर बैकएंड है, आपने 3 अलग अलग डेटाबेसेस में यू हैव स्टोर्ड द शार्ड्स. व्हेनेवर अ ट्रांजैक्शन कम्स, यू गेट बैक द शार्ड्स, you recreate the private key, return it to the user. What is the problem here? Is there still a central point of attack? The answer is yes. There is still a central point of attack. Your backend can still be hacked. Doesn't matter आपने private key को 10 जगह store कर दिया. If the backend gets hacked, backend will talk to all 3 of them, get the transaction signed and return it. There are 2 more approaches इसके बाद actually. This is how you should build up in an interview as well if you're ever explaining this approach. So what is the approach in Shamir's secret? We are just building a dumb clone right now. But if you're creating a company like BonkBot, like WazirX, so can you do this? Should you do this? The answer is no. Should you do multi-sigs? No, they got hacked with the multi-sig. Should you do sharding? Definitely not. All of these are bad approaches. Then what is a good approach? Here comes one more thing I will introduce today. MPCs, or multi-party communication. I was surprised to see that CoinDCX, which is the second biggest exchange after the hack, they also posted that we use MPCs for security. I was surprised because I did not expect any Indian exchange to know this much, but they did. So what is the sort of best approach? What everyone uses in a centralized exchange? It's an MPC. Can you use something similar here? Sort, you can. It will be a little hard though. I'll explain why. But you can use an MPC here as well. All right, last approach बता देता हूँ. We are going to probably just encrypt and put it in the database for our application. But MPCs are, sort of good for you to know कि क्या होते हैं. MPCs is not a crypto-specific concept. They are used in a bunch of places. The official definition is very weird. It's basically कि as the name suggests, multi-party communication. अगर 3 parties हैं and they all have some data, कि यार मेरे पास private key का कुछ part है, मेरे पास भी है. They don't want to share the data. I don't want to give this data to you. I don't want to give this data to a central exchange, central backend. They don't want to share this data, but they want to prove to everyone कि मेरे पास ये data है. Let's say there are 3 people, and sitting who have some numbers. I have a number 3, you have a number 5, you have a number 7. We need to prove to each other something. For example, we might have to prove to each other कि यार the sum of all of these, ऐसे कुछ example होता है to explain MPCs from first principles. Let's say this person has 3, this person has 5, and this person has 7. We want to not show our numbers to each other. हमें एक दूसरे को दिखाना नहीं है. There is a person sitting over here. He can't see this and this. ये बीच में partition है. There is a person sitting over here. He can't see this and this. There is a person sitting here. इन तीनों के पास numbers हैं. ये नंबर किसी को देना नहीं चाहते. They don't want to share the number with anyone. But they want to prove कि the sum of all the numbers that they have is 15. How can they do that? How can they prove to someone outside कि यार हमारा sum तो 15 है, but हम बताएंगे नहीं कि हमारे किस में से क्या है. We won't tell what we have, but we can prove to you कि we have a sum of 15. How do you do this? Even I forgot. There is some weird thing that you do. कि these people sum up their numbers. They don't share the numbers. They sum up their numbers. That becomes whatever. Let's say 5 plus 7 is 12. They share this with the world. कि हम दोनों के पास मिलके 12 हैं. Then these people also sum up their numbers. And they share with the world whatever. We have 8. And then these two people do the same. And then you know that the final sum of all three is equal to 2 into the sum of what they have. And that's how you sort of prove to the world कि हाँ तुम्हारे पास ये है. This is a very naive example that is used to just teach कि how MPCs are, what MPCs are doing under the hood. But of course under the hood वो ये थोड़ी कर रहे हैं. They do something else, very complicated math. Not a lot of people have written MPCs. Some very sophisticated trading firms have written, MPC का logic for private keys. हमें तो यही करना है ना. क्या कर रहे हैं हमें कि there are 3 different servers, databases, whatever, that have some shard of a private key. They don't want to share this shard with the central server, but they want to somehow communicate with each other and sign a transaction. If this guy gives them a transaction, इनको यहाँ private key नहीं दे देनी है कि भाई this is my shard, this is my shard, this is my shard, recreate it. No, they don't want to do that. They don't want to reveal the underlying private key, but they want to communicate amongst each other somehow without sharing any information and sign the private key. So this is the ideal approach that you use to create wallets in exchanges. The way it works is that you have one MPC running in AWS, one MPC running in GCP, one MPC running in one MPC machine running in, let's say, DigitalOcean. This is your backend. Whenever a user comes and signs up, you create a private key and share it with all 3. You create it such कि वो यहाँ कभी आए ही ना. You directly create the shards and put them over there. In fact, इसकी creation भी आगे ही देगी होती है. You never create private key. You tell all 3 shards to communicate amongst each other and create parts of the private key. आप अगर यहाँ create करोगे तो बात तो वहीं आ जाएगी. If you are creating the private key over here, you are screwed if your backend is down. This backend, assume, can always be hacked. Even these can always be hacked. But तीनों साथ में hack हो जाएं, इसकी probability is very low. All 3 of them getting hacked together, probability is very low. But it can still happen. But backend can definitely be hacked. So backend should never create private keys. जब भी request आती है, you forward an event to all 3 of them. जिसने भी MPC का code लिखा होता है basically. MPC is nothing but an HTTP server only. So whoever has written the code of MPC for private keys, MPC for private keys, जो trading companies बनाती हैं basically. The request that you send is / create a private key with ID1 / create a private key with ID1 / create a private key with ID1. The MPCs somehow communicate and create shards. All 3 of them know कि भाई बन गया. Then whenever you want to sign a transaction, you send a request to sign for user 1 this transaction, sign for user 1 this transaction, sign for user 1 this transaction. They individually sign it and then communicate back the signature to the backend. This is how exchanges do it. That's the 6th approach of building something like BonkBot or whatever. Private key management, kahan gaya? Never mind. So there are 6 approaches we have covered. One is private key in the DB, very bad approach. 2 is encrypted private key in the DB, very bad approach. Shards, bad approach. Multisigs, not too bad actually. This is a decent approach. A lot of companies would use this. It will not work for our use case. Shamir's, decent approach. And lastly, MPC, the gold standard for encryption right now. For private key management, this is the thing that almost everyone does. Okay, you have MPC servers in places जहाँ पे भाई you can just hope कि वो सारे एक साथ ना hack हो जाएं. They all don't get hacked together. You just hope that. And of course, if they all do get hacked, then you're screwed. You can't do anything. Do we understand? Let's do a poll. Do we understand the ways to do private key management? This was actually part of the second part of whatever the cohort. But then, good thing to discuss today. Anyways, we are just going to do this today. We are going to most probably just do this much. This is good enough. Even if you do this now, for now, even this is fine. Storing it in the database in plain text is fine. Both of these are very bad approaches. Both of these, if they get access to your servers, you are screwed. So 80%, pretty small number. Any specific questions? या फिर बस बहुत ज़्यादा हो गया? But Shamir secret is also same as previous one second. But Shamir secret also same as the previous, isn't it? Because if they have 3 parts, they can take all the funds from our wallets. If someone so you can create a 7x10 Shamir, right? अब उनको 10 में से 7 servers का access चाहिए होगा. If you have ever heard of Wormhole is a bridging protocol, slightly centralized. उनके case में भी I think they have 26 guardians. And if 10 out of 26 or some 20 out of 26 sign, then they approve. So yes, you will have a very big number, 20 verifiers. उसमें से कोई 10 भी verify कर दें, तो you are good to go. I don't think MPCs use zero knowledge proofs. I think they're simpler than that. Let me do MPC one more time. Yeah. No one writes MPC code. You'll find some libraries. I was trying to do it, but most of this is written in trading firms, and exchanges ask trading firms, "Kya ye code hame de do please," and you just use their API. It's very hard to write it. You have seen the code of one of these. It's sort of hard to write. All right. MPC और Shamir का बीच का difference से start करते हैं. What is the difference between a Shamir secret and an MPC? We'll start with Shamirs. Shamir secret में क्या होता है? यूजर आया आपके पास, उन्होंने कहा वॉलेट बना दो, प्लीज क्रिएट माई वॉलेट. व्हाट डिड यू डू? यू क्रिएटेड अ प्राइवेट की ओवर हियर. यू कन्वर्टेड इनटू 5 shards. आपने 5 शमीर्स निकाले उसमें से 1 2 3 4 5. यू सेंट द फर्स्ट वन इन दिस डेटाबेस कि भाई तो यहाँ रहे. दिस डेटाबेस हैज द फर्स्ट शार्ड, दिस डेटाबेस हैज द सेकंड शार्ड, थर्ड शार्ड, फोर्थ शार्ड एंड फिफ्थ शार्ड. You have 5 different databases, 5 different regions of AWS or 5 different cloud providers. Very low probability कि 4 में से 5 एक साथ ही हैक हो जाएंगे. Very low probability that 4 out of 5 get hacked. And you created a 4x5 Shamir. That way, अब whenever the user comes and says कि यार you have my private key ना BonkBot, please send 2 Sol to a friend of mine. So what does this guy have to do? It needs to ask all the databases कि यार जल्दी से इसका मुझे यार shard दे दो. तुम सबके पास एक shard है ना? Please return me the shard. As soon as it gets 4 shards, it can regenerate the private key, sign the transaction on the user's behalf. That is how Shamir would do it. कि Shamir in itself isn't executing. वो कुछ काम नहीं कर रहा है. Shamir is just an algorithm to break a private key and make back the private key. That is it. It will help you break a private key into few parts. Shamir का main appeal क्या है? What does it do? What are the functions? If you ever use a Shamir library, what functions it will provide you? It will provide you a break function that will take arguments like this. You will do Shamir.break, which means break this private key. You will give it the private key as the input, the number of partitions that you have to create 5, the threshold, let's say 4. You will call something like this to break the Shamir. What will it return you? It will return you an array of 5 elements. What is the other function you will call in a Shamir? .join. Shamir.join. You only have to give it 1 2 3 4 private keys in an array and खत्म. ये आपको original private key दे देगा. Key thing being, it expects you to write the logic to sign. Shamir क्या कह रहा है कि मैं ये बना दूंगा, I will give you back the private key. You have to write. अब तुम्हें original private key मिल गई है, do whatever you want with it. It gives you back the private key. It expects you to hold the private key and do whatever you want with it. Compared to an MPC. MPC क्या करता है? Taking an MPC as a black box, the thing that it does is, given your centralized server tells you something कि यार एक नई private key आई है, बना दो. The private key is not generated over here. It is not broken down into parts over here. It is sent to the 3 parties in this MPC cluster. If this is our MPC cluster of 3 machines, हम तीनों को बोलेंगे. The way it actually happens is, there is a Redis queue in which all of these events flow, and all of these MPCs are totally turned off from the internet. इनकी all they can communicate with is this Redis cluster. They don't that's not necessarily true actually. They actually expose an HTTP server. My bad, that's a different service. Either is fine. Long story short, or the main point being, कि व्हेन यू सेंड समथिंग टू एन एमपीसी क्लस्टर, आप सबको बताते हो कि यार प्राइवेट की का एक पार्ट क्रिएट कर देना, एक 4x5 प्राइवेट की बन रही है, यू क्रिएट इट्स पार्ट. इट्स लाइक ओके फॉर द यूजर 1 आई हैव पुट द फर्स्ट शार्ड विद मी, मेरे पास पड़ा है. सेम फॉर द सेकंड गाय कि फॉर द यूजर 1 आई हैव अनदर शार्ड, फॉर द यूजर 1 आई हैव अनदर शार्ड. All of these MPC machines will create a shard and store it. When you want to sign a transaction, आप उनसे shard नहीं मांगोगे. You will not ask them back for the shard and recreate the private key here. You will tell it कि यार ये transaction आई है, please sign कर दो. Please sign this transaction. All of them will partially sign the transaction. And then if 4 out of 5 have signed the transaction, you can forward that transaction object to the blockchain. Yeah, that's there is still a point of attack over here, which is this guy right here. इसकी भी बात करेंगे. Yeah, that will blow your mind. But ठीक है, पहले इतना समझ आया कि MPCs और इसमें क्या फ़र्क है. What is the difference between an MPC and a Shamir? Shamir में you regenerate the keys on your side. MPC में you have created multiple machines and you are delegating tasks to them. Private key बना दो, juice and sign करा दो, transaction कर दो, तो it will sign the transaction for you and you can rejoin the transaction over here, broadcast it to the network. Do we understand this now? MPC versus Shamir. There is still a central point of attack over here. We'll talk about it. We understand this. What is the point of attack now? हिली नहीं वैसे घंटी, back at 83%. Let me do, oh my god, it's already 8:44. Let me do just 1 minute of Q&A. Then I'll talk about one last thing and then we'll move on to coding. You don't know what BonkBot is using. They will not share this with anyone, but I know a Telegram bot that does some 200k a day, or not 200k a day, 200k a day in volumes, not revenue, in volume. So their revenue is like 2k a day, something like that. They are just encrypting and putting it on the private key. Confused in MPC again. What if signed transaction is hacked? Sort of, that's sort of one point of attack over here that I'm going to talk about. The following MPC approach, we are not even creating the private key in our backend. Yes, we are not creating the private key in our backend. It is being generated in by various parties. That is why I said when wormhole is such a big, I don't know if you've heard of it, it's a very big protocol. अगर वो प्राइवेट की यहाँ बना के बांटने लग गए पार्टीज में, they can screw you over. But if the parties are themselves creating shards or whatever private key के parts, then wormhole can never attack it. ये कभी अटैक नहीं कर पाएगा. But there is a central point of attack. We'll talk about it. What the signed transaction is hacked, that's sort of the problem. Is BonkBot using MPC approach for private key management? We don't know. Until they tell, we don't know. Some Telegram bots doing good volumes, having good number of wallets and total volume logged, are just encrypting the private key, putting in the database. If yes, you mentioned we can eject BonkBot. Exactly. So two things. It is a private key only. Just because it is put into 3 parts, 4 parts, doesn't mean you cannot create the original parts from it. When you do MPC, you're actually putting Shamirs only. This and this is just a shard of the Shamir. It's just stored somewhere else. तुम उसको यहाँ नहीं बनाते हो बस. That is it. So you can always, your MPC can always support another function called rejoin, जहाँ पे it will return you the shards and you can regenerate the private key. So it's not like you can't regenerate the private key. It's not like that there isn't a single private key. There is still a single public key, right? There is a single public key, still a single private key. To regenerate it, the parties needs to again talk to each other and then return it. Okay, so a few people. What if the signed transaction is hacked? Are you talking about Diffie-Hellman? Yes, I mean not Diffie-Hellman here, but it's very similar, the algorithm. In fact, if you look at the video that I was talking about, they first talk about Diffie-Hellman and then talk about MPCs. Difference between checksum and digital signatures. Checksums are just a hash of everything. Okay, checksum is basically if this is your very big file, इसको hash करके checksum बना दिया ताकि if some part is changed, the hash also changes. You can ensure that the final thing is the same. there's no signature over there. It's just hashing a very big thing into a small thing. So that अगर छोटा सा भी change हुआ, you can figure it out. Signature में there is always there is a public key private key that verifying कि हाँ this was actually signed. All right. WazirX was an MPC hack or a multi-sig hack? WazirX did not use MPCs, from my knowledge. It was a multi-sig hack. In fact, they did not even create their own multi-sig. There is a very famous service on Ethereum for multi-sigs, which is what they used. And the speculation is उसका front end break हो गया. उसका नाम भूल गया मैं. I've talked about it in my video. But their front end of that very famous service apparently was hacked, which led to it. They did not use MPCs. One common question that should come to your head is, हरकीरत अगर back end ही hack हो गया तो if this is cluster 1, cluster 2, cluster 3 doesn't matter. अगर developer of the company becomes shady, what can the developer of the company do? वो यहाँ आएगा and एक request भेज देगा सब MPCs को, यार please sign this transaction to empty this wallet. MPCs will be like, oh, the request came from the backend. MPCs will oblige and all the money will go to the developer's account. I repeat, this backend is in the end deployed on an AWS machine only na. This backend can talk to the MPC cluster na. So the developer can just SSH in here. A random developer, full stack developer कि भाई I need to make a lot of money, will SSH here, send all the MPCs, क्या सबकी transaction sign कर दो, वो कर देगा. How can you get rid of this? And this is a $100 bounty if you guys can tell me. I will repeat the question. The question is, if this is a backend and this is the MPCs, we said something very smart until now कि private key management हमने अपने database में भी नहीं करी है, backend में भी नहीं करी है. All private keys are stored over here. Very hard to hack 4 of these machines together. But what if the backend gets hacked? Whoever hacked the backend can send a request to all 4 of these. क्या खाली कर दो सबके wallets. Empty up everyone's wallets. All the MPCs will oblige. All the MPCs will be like, सही है, हमें तो हमारा जो backend है उसी ने भेजा है, but backend end user ने नहीं भेजी request. The end user did not hit an endpoint that you forwarded to the MPC. The request came directly from the backend. यहाँ पे एक developer गया and he started to talk to all the MPC, sign कर दो, and सबके wallet खाली कर गया. It emptied up everyone's wallets because the developer directly from here sent request here. There was no request that came from the end user. The end user never sent you anything. You directly from the backend घुस के वहाँ चले गए. Problem तो समझ आ गई. Simple problem to understand. First thing you would think of if you're in an exchange, yeah, this is how we'll hack. Ooh, I think someone said something. Oh, if the CEO has access to it, that's equally bad. Someone said something which is very close to what we want, and I think that deserves a bounty. What if I create a PDA with the platform private key and the user credentials and seeds and bump? And when the user asks for the private key, they only create and send their funds to the newly created wallet. What if I create PDA with the platform private key and user credentials? Okay. And when you can do that, but you will create a new wallet for them. What if the blockchain is, people want to own the wallet they are seeing. मान लो आपने जो wallet, you are saying कि मैं एक random wallet बना दूंगा, whenever the user wants to eject, I will move their funds to the new wallet. They have done thousands of transactions here. They deserve some airdrops from some random company. तो उनको वो airdrops मिलेंगे ही नहीं अगर वो सारे transaction यहाँ से यहाँ गए. Airdrops will all be redeemed by the company. So you do not want this. कि when they eject, you move their funds to a different wallet. You want them to give the private key. User side validation is actually the answer. The question is, what do you mean by user side validation? Asking users for a private key they have. Exactly. That is exactly. Wow. 2 people sort of answered it. So we'll split the bounty between both of you. Check whether the request is coming from, yeah, that's sort of right. Non-custodial system, only the CEO has access to it. If it hacks from the request, only CEO has access to it, no verification. Yeah, so most of these are not right. If the CEO has access to it, that's fine. If the CEO can hack it, so that is not fine. That's equally bad. The way it works, which is, an overkill approach, but the approach that is followed is, as someone said, user side validation and someone else said some private key on the user. If this was an interview, I would tell you this. कि यार दिस इज नॉट अ प्रॉब्लम फॉर वर्म होल. अभी थोड़ी देर पहले आई वाज टॉकिंग अबाउट वर्म होल. वर्म होल is something very similar. It's a little different. It lets you move USDT from Solana to Ethereum. 5 मिनट और ओवरकम करूंगा, फिर सिंपल कोड लिखेंगे एकदम. 5 more minutes, then we'll start to write code. Wormhole lets you move assets across blockchains. How? We'll get to full architecture. The way they work is they're also mildly centralized. उनके केस में भी एक सेंट्रल सर्वर सा है, and they have a bunch of guardians. जब भी कोई यूजर की ट्रांजैक्शन आती है, whenever a user transaction comes, it goes to the guardians. If some of them approve, वो transaction is considered to be approved. Very similar. They are fully on chain though. They are fully on chain. अगर मैं अपना USDT Sol से Ethereum भेजना चाहता हूँ, I sign this message using my Solana private key. I sign this message using, let's say, my Ethereum private key. तो इवन इफ दिस गाय इज फॉल्टी, ये कुछ भी गलत करने की कोशिश करेगा, तो दे विल नॉट एक्सेप्ट इट. ऑल 4 ऑफ देम विल चेक कि क्या ये रिक्वेस्ट यूजर से आई है. हुएवर इज सेंडिंग द एसेट्स, हैव दे साइंड अ प्राइवेट की और द मैसेज यूजिंग देयर प्राइवेट की. सो द रीजन इट डजंट हैपन इन वर्महोल इज बिकॉज no centralized layer can tell the guardians to do something. Only the end centralized layer can take their message over there. They don't have the private key of the user, so they can't send it. That is why the answer that someone said, which was private key, is right. कि अगर आप centralized system भी बना रहे हो, even if you are building a centralized system, when the user signs up, they get issued a private key. When the user signs up, उनके लिए एक और प्राइवेट की बनती है जिसका कोई वजूद नहीं है. इट डजंट होल्ड द यूजर एसेट्स. इट इज जस्ट सो दैट कि वो प्राइवेट की इस यूजर तक पहुंच जाए. एंड एवरी ट्रांजैक्शन दैट द यूजर डज, दे हैव टू साइन द मैसेज. सो इवन इफ द सेंट्रलाइज सर्वर इज हैक्ड, दे कांट साइन द मैसेज ऑन बिहाफ ऑफ दीज यूजर्स. ये प्राइवेट की सीधा मतलब इस सर्विस के बीच में और एक साइन अप सर्विस के बीच में शेयर्ड होती है. दिस प्राइवेट की सॉर्ट ऑफ, एंड ऑफ कोर्स विद द एमपीसीज एज वेल, बिकॉज दे हैव टू वेरीफाई. But this is how you make sure कि वो ये वाला अटैक भी ना हो. In fact, if you open backpack ever, you will see कि local storage में there is a private key stored. उस private key का कोई वजूद नहीं है. Backpack or any other exchange if you open and you open the local storage, you will see यहाँ पे एक private key है. This isn't your assets private key. This is a random private key that you are signing every transaction with, so that जो भी request आप भेज रहे हो is signed by you from the browser, so that the server cannot tamper that request. यहाँ पे कोई डेवलपर आएगा, दे कांट साइन ऑन योर बिहाफ. ये प्राइवेट की सिर्फ आपके पास रहती है, आपके ब्राउजर में स्टोर रहती है. दैट इज हाउ यू डू रियल प्राइवेट की मैनेजमेंट, सर्वर क्लाइंट. एंड कोई भी पॉइंट ऑफ अटैक नहीं है. देर इज नो सिंगल पॉइंट ऑफ अटैक. इफ योर एमपीसी क्लस्टर गेट्स हैक्ड, ऑफ कोर्स यू आर स्क्रूड, बट इफ योर बैक एंड गेट्स अटैक्ड, इट्स फाइन. इफ द यूजर का फ्रंट एंड गेट्स अटैक्ड, दे आर ऑल्सो स्क्रूड, बट यूजर का फ्रंट एंड फिर उसकी रिस्पॉन्सिबिलिटी है ना. भाई अपना यूजर नेम पासवर्ड मत शेयर करो. डोंट शेयर योर यूजर नेम एंड पासवर्ड विद अदर पीपल, यू विल बी फाइन. The private key stored in your local storage. Don't give your laptop to your friend. You are fine. This gets attacked, can do nothing. You can't really ask NPCs to do anything. They will not comply to your request. They will wait for कि भाई user signed request है तो ही मैं करूँगा. And lastly, MPC में of course if the cluster gets hacked, you're screwed. But the cluster is so well decentralized. This is a decentralized application only. There are 6 different verifiers, miners, whatever, that are verifying this transaction. Cool है. Too much private key discussions for a day. Let's do a quick poll. Let's move on to the project. I think more than enough समझ आ गया होगा. नहीं भी आया होगा तो मतलब we are going to do this again. I was looking for a MPC implementation so we can try to write this ourselves also. Eventually, like when we reach the private key management part. But for now, Harkiyat, let's do the difficult bits. Why do you have to build this? Because you will not be able to build this. I can tell you 90% will not be able to code this today, even though we have done all of this. So can we quickly do it? Can you quickly create a sign up route that gets hit whenever the user goes to your Telegram and signs up, or goes to your website that signs up? What is this sign up endpoint supposed to do? It will generate a private key for the user. Store it in memory, it is fine. Store it in MongoDB, it is fine. Store it in Postgres, it is fine. Doesn't matter. For now, ये तो simple part है. These are Web 2 bits. You can figure them out as you progress through the Web 2 cohort, and you can understand how sign up, sign in works. How do you store users' information? Only extra thing we are storing, users' private key. Private key will be stored. Public key will be returned to the user. When the user signs up, when I go to BonkBot and say hello, it returns me my प्राइवेट पब्लिक की, कि तुम्हारी पब्लिक की ये है भाई, प्राइवेट की हमारे पास है, पब्लिक की है. सो साइन अप एंड पॉइंट नीड्स टू डू दिस. व्हाट डज द साइन इन एंड पॉइंट नीड टू डू? यूजर आ रहा है, साइन इन कर रहा है, उसको एक टोकन लौटा दो, रिटर्न देम अ JWT कि हाँ भाई एवरी फर्दर रिक्वेस्ट सेंड मी द JWT, आई विल साइन ट्रांजैक्शंस ऑन योर बिहाफ. एंड देन ओनली 2 more endpoints. यूजर विल आस्क यू टू साइन अ ट्रांजैक्शन. एक्चुअली दिस वन इज गुड इनफ, ये भी बना दिया तो सुपर इंप्रेसिव. यूजर विल सेंड यू अ ट्रांजैक्शन कि यार ये ट्रांजैक्शन है मेरी, प्लीज इसको साइन कर दो मेरे प्राइवेट की से. द बैकएंड नीड्स टू साइन इट एंड फॉरवर्ड इट टू द ब्लॉकचेन. इट हैज 2 arguments here, retry true or false. मतलब if this transaction fails once, the backend will keep on retrying it. If retry is true, let's say it will retry 5 times. If it is false, the backend will try it once. Fail हो गई तो fail हो गई. And then lastly, the fourth one that I've asked for here is asking the status of an existing submission of mine. क्या मैंने थोड़ी देर पहले आपको ये साइन करने को बोला था. Have you signed it? What is the status of my transaction? And you know it can be processing, success or failed. ये जो ID है, this ID is not your transaction hash. This is the ID you get back when you send a transaction. जब मैं backend को एक transaction भेजता हूँ, it returns me an ID because immediately तो transaction blockchain पे जाती नहीं है. The transaction does not go to the blockchain immediately. The transaction goes to the blockchain, you know, whatever. Sometimes in 5 minutes also in Ethereum, in Solana also, you can keep retrying for 5 minutes. So when the user is sending you a transaction can be anything. I want to send Solana. I want to receive Solana. Sorry, not receive, send USDT. I want to buy an NFT. The user is sending you that transaction object. You will sign using the user's private key, and this you will forward to the blockchain. You will return the user a random ID. ID 1. Your transaction has been recorded. Your ID is 1. And then user can keep polling you. क्या ID 1 का क्या हुआ? And then you let them care your signature is still processing. Okay, it is done. It has succeeded or failed. So that is how you're going to, you know, build the 4th endpoint. Can we start to code it? Can we create the front end and the back end? Here are some hints for when you get stuck. Maybe one more thing I'll talk about is serializing transactions in Solana. Basically, जो transaction object आप front end पे बनाओगे, you need to convert it to a string before sending it. You can't send a complex object to the back end. तो transaction.serialize will serialize it, convert it to a string. Backend में you can deserialize the transaction. That is it. These are the 3 hints. This is the project. I'll answer Q&A for 5 minutes. Then I'll start to code it as well. But तब तक के लिए, can you initialize a backend, have a functionality that lets the user sign up and sign in, and maybe one that lets users sign a transaction also. If you think you cannot do this at all without going to an AI, so let me just code it. So you know, let's do a poll. Then there's no point. आप AI से पूछ रहे हो, मैं बता देता हूँ. But if you think कि you can scramble a bit and try to code it yourself, then you should code it. Because I'm here, I'll answer doubts. Eventually, I will code it also. So I've already coded. I have the code. I'll share the code with everyone. Don't worry. So next poll: should I code it right now? Yes or no? If you say yes, I will start to code immediately. You can follow along. If you say no, you will try coding for 15 minutes. Then I'll jump in and help out a little bit. Then we'll keep going from there. Should I start coding myself? Yes or no? Makes sense. So that's a yes. All right. Not disappointing at all. ठीक है जी. We will start coding. What is the first thing we have to do? We have to initialize a front end and a back end. अभी के लिए we are not building the front end on Telegram. We are building the front end on React. We are building the back end in Node.js. We are not building a Telegram bot back end. जब आप Telegram bot बनाओगे, तो you'll have another service that will talk to the user and forward request to your backend. अभी के लिए our client is a React app. So first thing you have to do is create an empty folder. Call it week, I don't even remember now, 14 I think, class. And let me open it in Visual Studio Code. Let me create 2 folders in here. Front end. Let me just create backend as a empty folder. And let me run npm create wheat@latest to create a React front end. Empty front end, empty backend, nothing too complicated right now. I'm going to select React as the framework I named my project client over here, and it created an empty React project. I have a backend folder where I'm going to write my code, specifically the backend for whatever was written in the Notion doc. So let's write the backend first. Always a good idea to first write the backend, then build the front end. Let me go to backend. How do I initialize an empty backend in Node.js? I can write npm init-y to initialize a package.json. If we were using TypeScript, we would have done a bunch of other things. We haven't yet covered TypeScript in the cohort, so I'm not going to complicate it. I'll create a simple index.js file. To recap, I initialized an empty React project over here, an empty Node.js project over here. What will be the dependencies in my Node.js project? Express will be one. At Solana /web3.js will be another one. Express is the HTTP framework. This is the library we will use to sign transactions, create public keys, create private keys, forward them to, the RPC. So here, let's initialize our React application. Let me turn off AI here. What is the first step? You need to import Express, which is our HTTP framework. Simple Web2 stuff. Const express equal to require express const app equal to express. That is step 1. What is step 2? Exposing the endpoints. app.post/API/v1 /signup. We have a post endpoint for signing up. Let me just return for now message sign up over here. I have bootstrapped first endpoint for today. What is the second endpoint? /sign in. What is the third endpoint? /transaction/sign. What is the first endpoint? It is a get request to /transaction. What is the fourth endpoint? It is a get request to /API/v1 /transaction. Nothing complicated here, hopefully. Let me decrease the size. This is what we have built until now. Last line I will add app.listen 3000 and it will start my backend listening on a specific port. Nothing too complicated here. To recap, initialized an empty Express application. This Express application will be talked to by our end clients. End client हमें कुछ request भेजेगा. If they want to sign up, we generate a private key for them. If they want to sign in, we give them a token. If they want to get a transaction signed by us, they will send us the transaction. We will sign it on their behalf. This is approach number 1. If you remember in the beginning of the class, I said there will be 2 approaches. Let me quickly explain what I meant when I said कि 2 approaches होंगी इसकी and why one is better than the other. I said in the beginning of the class, there will be 2 approaches to solve this. Approach 1 is, if this is the client, the browser, they will create the transaction object. They will serialize this transaction and send it to your backend. Your backend will sign the transaction and put it on the blockchain. Approach number 2 is that the client will tell you what I want to do. BonkBot mein, you don't have to do too many things. Let the user eject their private key. Let the user transfer Solana. Let the user buy a meme coin using Solana. Let the user transfer the meme coin. बस 4 ही चीजें सपोर्ट करनी है. तो it makes sense कि यार आप अलग अलग endpoints ही बना दो ना. 4 different endpoints where the user can simply tell you कि hey, please send Solana to this address या please buy meme coin XYZ. So the second approach is कि यहाँ पे कोई Web3 का लॉजिक होगा ही नहीं. There is no Web3 logic over here. You tell the backend what to do. It creates the transaction object here directly, signs the transaction object, puts it on the blockchain. This is approach number 2. Which one is a better approach? For Telegram bot, this might be a better approach. Why, Harkirat? Because you don't know what the Telegram client looks like. आपको नहीं पता कि जब वो Telegram खोल रखा है बंदे ने, can you write JavaScript code over here? You can, like bots में you can write it in the backend, but you don't know which will be the client. How will you create a Web3 transaction here? How will you serialize that transaction? It's much easier to do if this transaction is sort of created on the backend itself. अगर ये transaction सीधा backend में ही बनेगी, I don't have to import at solana/web3.js here. The client can be fairly dumb. Client can simply send an HTTP request कि मुझे ये करना है, or I want to do this. The backend is what will serialize, create the transaction, serialize it, put it on the blockchain. So approach 2, approach 1. You will learn more from approach 1, which is why we are going with approach 1. But approach 2 is sort of, better for Telegram. It might not be better for something like TipLink. For TipLink, user can send you any random transaction. So उस case में you can't create so many backend endpoints. But here the user only has to do 4 things, so simple enough. If you do the first approach, second approach is much simpler to code. Let's code the first approach. Sign up, sign in, figure out कर लोगे खुद से या मैं लिखूं? You can create a MongoDB database. I can create one if you want, and I can do CRUD operations there. Do you want to do that? Should I do CRUD operations? Alrighty. It'll become more of a full stack class then, but happy to do it. You should do it in Postgres. Mongo is also fine. So what is step 1? I need to create a MongoDB database. How can I do that? Docker run Mongo. What is the port that MongoDB runs on? MongoDB port. Docker. So what am I doing? I'm starting MongoDB locally so that I can put data in there locally. Where is the port mapping? Default port Mongo 27017. Sorry, I don't use Mongo at all at work. Neither should you. So I don't know what the default port for Mongo is. There you go. Oh, sorry, I put an extra colon over there. What is the command I'm running to start MongoDB locally? I'm running docker run -p 27017 :27017 Mongo. Now the people who have not done full stack, this will be a little jarring. So what you can do is you can go to cloud.mongodb.com and get a free MongoDB instance from here. What is MongoDB? It is going to be our database for today. So I can sign in over here and quickly create a database. That works as well. Or you can just start it locally. Generally always a good idea to learn how to run Postgres locally, how to run Docker locally, how to run MySQL locally. Docker makes it very easy. So if you don't understand this command, we'll do Docker eventually. I have a free video on YouTube. उसको देख के समझ आ जाएगा. This is how I'm just starting MongoDB locally on my machine, ताकि मेरे को cloud instance ना लेना पड़े. I can also buy a cloud instance. I can also get a free one over here. If I log in over here, I can get a free MongoDB instance. We have already covered in the web dev cohort, so not recovering. All right. While this is happening, what library do I have to bring in the backend next? npm install Mongoose. What is Mongoose? It's a library that lets you connect to MongoDB to put data in there, get data from there, so on and so forth. After I've gotten this library, what do I have to do? I have to define the models of MongoDB. So I can create a models.js file जहाँ पे I can import Mongoose and I can call mongoose.connect. This would connect to the database. Ideally, I should wait for the connection to happen, but I'm just going to wing it. I will start to create my schemas. What would be my database schema here? There will be a users table. Which will have what? The username, which will be a string. password which will be a string, private key which will be a string, public key which will be a string. इसको छोड़ के कुछ होगा नहीं. Do we need another table? No. Simple enough. You need one table where you are going to dump the data of the user. Once you have created the schema, what is the next step in MongoDB? You create the model of it. Const user model equal to user schema dot mongoose dot model. Name of the model, I'm going to call it users, and then the schema of the model, which is, let's say, user schema. This is how I create the user model. Let me export it from here. Module.exports equal to user model. समझ आया? थोड़ा तेज कर दिया मैंने. But if you have gone through the MongoDB class, this should be straightforward. What am I doing? Requiring mongoose, connecting to MongoDB, creating a schema for my application, creating a model out of it, returning the model from here. Why am I doing this? मैं model क्यों return कर रहा हूँ यहाँ से? So that in index.js, यहाँ पे I can import the model from here. I can write const user model equal to require dot slash models. क्या लिखा है मैंने कि यार user models ना एक object में मिलेगा. This will return you an object xyz, let's say. xyz will look like this. It will have whatever user model as a key. तो या तो I can write this const user model equal to xyz dot user model. I can write this, or I can destructure it directly over here. That's how I get the user model. What will I use the user model for? To create a user over there. So I will call user model dot create. क्या user ने एक username और password भेजा है. Const username equal to rect dot body dot username. What am I creating? The sign up endpoint. User has sent me a username. User has sent me a password. What should I do at this point? Validate the inputs, check if the user already exists, hash the password. I should do these three things. I am not doing it, assuming you can do it. We have done it in the classes. So I am not validating the inputs using Zod. I am not checking if the user already exists. I am not hashing the password. I am storing it in plain text for now. So what can I do? User model dot create. क्या user ने ये username भेजा है? Username ये password भेजा है. But what is the problem? What is missing over here? The private key and the public key. हमें उसके लिए एक public private key generate भी तो करनी है. So what can we do? At this point, we can create a random public key. We don't care. Const key pair equal to new key pair. If you remembered, this key pair class in Solana creates a fresh wallet for you. Fresh public key, fresh private key. You get the key pair. What do you do with it? You simply store के भाई public key is password dot public key. Private key is key pair dot private key. Is this enough? इसका type क्या है भाई? Its type is a class itself. It is not a string. What is the type of this guy? I think it's secret. Secret key. Its type is uint8 array. तो ऐसे डाल दोगे क्या? Can you put an array जहाँ पे एक string जानी चाहिए? Can you put a class जहाँ पे एक string जानी चाहिए? No, you can't. So you have to convert this to a string. This, even if you don't convert to a string, I think MongoDB will do it. But let's just explicitly do it as well. इससे हमारे password में एक ऐसी private key store हो जाएगी. A bunch of bytes. A very big uint8 array. That is exactly how you store private keys in Solana. If I show my private key dot Solana config slash Solana slash id.json, अगर मैं इसको log कर दूं अभी, what you will see will be a bunch of zeros and ones in an array. That is how you store it on your machine, a private key. That is how you can store it in your database. You can also store it, convert it to a string and store that as well. You can convert it to hex, store that as well. Or you can keep it like this. Either is fine. Return क्या करना था user को? We have to return them their public key. key pair dot public key dot toString. Was this too difficult? There's like one line of code here that is Web3, everything else is Web2. So, practice a bit, you should be able to do this. By now you should have created a few CRUD applications. This shouldn't have been too difficult to build. Sign up endpoint is done. What should be the next step? Sign in endpoint. What will the sign in endpoint do? Get the username and password from the user. What will it do next? It will check क्या कोई user exist करता है with this username password. We have not done hashing of the password right now. So for us it will be very simple. Const user equal to user model dot find. First होता है I think, या find one होता है. I will have to recheck this कि what exactly is the function. Find one where username is this username and password is this password. And then if it is correct, then what will you do? Return the user back a token. Harkirat, what token? A JWT, right? We have done it many times. So hopefully this is simple enough. Create a JWT, return it to the user. Harkirat, how do you create a token? We have done it a few times. I can do it really quickly. It'll just make the code a little bit longer and harder to digest. I think we are not focusing on the right code, which is this endpoint. This is where we should be focusing. This is Web2 stuff, which is simple, but chalo, I will still do it. What did the Notion doc say? क्या जब बंदा sign in करे, they should get back a token, a JWT. So what will we have to do? Create a JWT for the user. तो what will I do यहाँ पे? कि यार username password आ गए. Let me find a user. अगर मिल गया सब सही, अगर नहीं मिला तो I will send them back some bad status code. कि यार sorry, credentials are incorrect. Something like this. But अगर मिल गया, then what do I have to do? I first have to generate the JWT. उसके लिए I need to bring in the JSON web token library. So npm install JSON web token, and then const JWT equal to require JSON web token, and then we create the token over here, jwt.sign. What will the payload be? Probably the ID of the user. User यहाँ पे await डालना पड़ेगा. I can't. This is an asynchronous operation, might take some time, so I have to await it. If I want to put an await over here, I also have to put an async over here. The same is true for the sign up endpoint. Sign up endpoint mein, I have to put an async over here. I have to put an await over here. Find a user with this username and password if they exist. Create a token for them. Return them back the token. Our sign up and sign in endpoint done. Let's try them out. जब तक try नहीं करेंगे समझ नहीं आएगा. What is missing over here? Whenever you are signing a JWT, you have to give it a password. You have to give it a JWT secret. So let me create a global variable called JWT_secret. यहाँ पे and hard code it to 1 2 3 4 5 6 for now. कल को we will change it. Sign up endpoint post, sign in endpoint post are done. Easy endpoints are done. It is a CRUD application storing things in a database. We are not storing things in memory. Database भी वो है जो हमें आता है. MongoDB we have done many times. Let's see, does it work? I'm sure it will not. I've missed some function calls and MongoDB syntax from time to time. I'm sure I'm going to, it will not work in the first go. But let's try it out. Are we missing something? We are using rec.body over here. What does that mean? I have to do a app.use express.json. Otherwise, it will not be able to parse my body. Again, we have covered this already. So this was the code that was expected to be written. Of course, we will have to fix some bugs. I don't know if this will start to work immediately, but this was the code that was expected to be written. Okay, whenever the user signs up, get their username and password, create a new key pair for them. You should do these things. I have not done them. Create a new user, return the user back. Hey, this is your public key. Same thing over here. When the user signs in, check, does a user exist in the database? If it does, return them a token. If it doesn't, return them, credentials are incorrect. Let me push this code, then we'll do a poll and then we'll proceed. I'm pushing this code so you can pull and continue from there if need be. I think this is week 14. I could be wrong. Web3 14 or 15. Alright, I've pushed all the code onto a repository. Let me paste a link to the repository in the chat and we can go from there. Alright, my next question to you was going to be, should I move on to the private key management signature stuff? Yes or no? If you say no, then I will test this, make sure MongoDB is working, data is going there, things like these. I'm sure there's something in the code right now. This is not find, this is find one or find first. So it's छोटे मोटे bugs होंगे. So should I continue to the verification logic, signing logic? Yes or no? If you select yes, we'll move on to the Web3 bits for today. If you select no, then I'll do the Web2 bits as well. Happy to complete the whole application. Should I move on to transaction signatures? Yes or no? All right, thank you. Cool. Moving on to the main bits. हमें क्या करना है? User will come to our website. What does our website look like right now? Simple front end, nothing, has nothing. So let me go back a folder. Let me go to the front end folder. Let me run npm install in the front end folder. Install all the dependencies over here. That's taking longer than I would hope for. जब तक ये हो रहा है, let me go to source/app. Oh, I initialize the TypeScript repository. Let me do JavaScript because I know we haven't covered TypeScript yet. I've reinitialized the client. I'm replacing, selecting still React, but selecting JavaScript as the language, not TypeScript. npm install the dependencies. And let me get rid of all the boilerplate code over here. Now comes the first complicated task for today. Serializing transactions. What do we want? कि यूजर आएगा, साइन अप करेगा, प्राइवेट की बन जाएगी. उसके बाद we want कि यूजर कैन सी सम सॉर्ट ऑफ एन इनपुट बॉक्स कि यार I want to send, placeholder is amount. I want to send this much Solana to this address. So they will see two input boxes and one, let's say, button where you write submit. I'm writing in this in the wrong file. Let me open client source app.jsx. यहाँ पे tsx let me delete. मेरे वाले में है because I had it open in the editor. So let me delete the tsx file. You will not have it if you have a React application locally. You will have a JSX file. I have removed all the code from here and made it very simple. input box button. Let's see what it looks like. If you look at the front end, if I run npm run dev over here and open the front end, you will notice I have two input boxes and a submit button. अब जब मैं submit button पे click करूंगा, when I click on this button, I need to create a transaction and tell a backend to sign it. कि यार मेरे पास तो private key है ही नहीं. I am a random user that signed up on the website. Can you please sign the transaction on my behalf, send it to the blockchain. So let me write a function called send sol, which is going to transfer the Solana. Simplest thing we're doing for now. Then we'll understand more complicated things. How can you send custom tokens? How can you buy a meme coin? Things like these. But abhi ke liye simple. Sending Solana from me to someplace else. You can do the same in Telegram. If I open BonkBot, I can withdraw X Sol. I can send some Solana to a different wallet address of mine. So same functionality we are supporting. I want to send Solana to some different wallet address of mine. So what is the transaction? होता क्या है ये? When you want to send Solana, you are sending some bytes to a program on Solana. That is it. Some zeros and ones, you send it to a program on Solana. To create those zeros and ones, we usually thankfully have some helpers that the Solana / web3.js library returns us. So let me first install this library. And thankfully this library has an export called transaction, an export called connection, a bunch of other exports, public key, that we will need. Key पर तो नीचे होगा. Thankfully ये already बना हुआ है, तो we did not have to write the logic to figure out कि वो bytes होंगे क्या. What are the zeros and ones I need to send to the blockchain so that it tells the blockchain कि मुझे अपने one sol यहाँ भेजने हैं. All that logic is written inside these exports. It might not exist in Kotlin. अगर आपको mobile app बनानी है, it might be hard for you to figure out how can you create this bytes of data. It might exist also. There also might be a Solana web3.js library or Solana web3 Kotlin library, but it might not also. That is why I said there is a other approach which is better. पर अभी के लिए we are going with the difficult approach. यहाँ पे क्या करना है? First we have to create the transaction. Let me stop Super Maven here. First we have to create the transaction. If you remember from the initial classes, when you're sending a transaction to the Solana blockchain, you're actually sending some underlying instructions. So dot add, I want to add some instructions. And हमारा user क्या करना चाह रहा है? They want to transfer Solana. So here I'll write the system program dot transfer instruction. ये क्या करता है? This function will create the transfer instruction. I am trying to send a transaction. इसके अंदर मैं multiple instructions भी भेज सकता हूँ. I just want to send one for now. So I can write const instruction equal to system program dot transfer. And what are the transfer parameters? From public key to public key and lamp ports. मुझे कहाँ से कहाँ कितना Solana भेजना है? Simple enough. From where do I want to send Solana? From my public key. Where is my public key? Backend will return it to me, right? Backend मुझे public key मेरी लौटाएगा whenever I sign up or sign in. For now, let me use a random public key I have. यहाँ पे I have this random wallet with a random public key. Or no, let me just use this one. Here is a random wallet I have that has $2. इसकी public key let me put over here. From here, I want to send money where? I want to send money to another random wallet, let's say, or let me select the third wallet over here. This is another wallet of mine. And how much do I want to send? Let's say I want to send 0.001 SOL. This has created an instruction. I can add this instruction to the transaction. What happens if I add this instruction twice? मैं 2 बार भेज दूंगा उन्हें. What if I send it thrice? I'll send them Solana 3 times, but I just want to send them Solana once. So I create this transaction object. Now, until now, we were doing some tx.sign or some wallet adapter.sign transaction, or connection dot send transaction, if you remember. अभी तक हम ये कर रहे थे. But can I sign this transaction? Can the browser even send this to the blockchain? It cannot. इसके पास private key ही नहीं है. I just know my public key. When I signed up, I got back my public key. I never got my private key. So I will have to tell the backend कि please sign on my behalf. So what will I have to do in this send SOL function? I have created the transaction. I have to somehow send this transaction to the backend. The problem is, ये तो एक class object है. How do you convert a class object or send it over the wire? You can send bytes over the wire. You can send images over the wire, or whatever. Images converted to base 64 over the wire. You can send JSON. You can send XML. You can't send a random class object. The backend on the other side might be in Python. उसको थोड़ी समझ आ रहा है कि transaction object भी कुछ होता है. So this class, you can't really send over an HTTP server. What can you send? You can convert this to a string, or you can convert this to a bunch of bytes and send that. So next step is convert the transaction to a bunch of bytes. And thankfully, this transaction class has a serialize function that you can call. When you call this, as the name suggests, converts the transaction into zeros and ones that you can send over the wire. We'll log it and see this very soon. But once this is done, what do I have to do next? I have to hit an endpoint on the backend. I have to call Axios. Let me install Axios. Axios dot post slash API slash v1 slash transaction slash sign. What is the body I want to send in? If you look at the Notion doc, what was the body that was expected to be sent when the user asked to sign a transaction? Message, serialized transaction, retry can be true or false. Let's say false for कि backend एक बार try कर ले, होता है ठीक है, नहीं होता है कोई बात नहीं. I'll send this request, get back a response, and then I can poll back with that response ID. ये जो ID आएगी वापस, I can keep polling the backend कि मेरी transaction हुई है like that. I can't put an await over here until I make this function async. I've created the instruction, created the transaction, serialized the transaction, sent it to the backend. Is this good? Would have been good, but it's not this easy to serialize a transaction. Whenever you serialize a transaction, it checks कि यार ये transaction तो sign ही नहीं हुई. This is a transaction that is expecting you to transfer money from this wallet. It was never signed. So this serialized tx.serialize will fail with an error. It will tell you कि आप serialize कर रहे हो transaction को. That transaction hasn't been signed yet, so I will not serialize it. Let's try it out and see how it breaks. Let's start the front end. Let's go over here. Let's click on the submit button. I clicked on the submit button and nothing happened because I never put care button on click equal to send SOL. Whenever you click on the button, call send SOL function. Now if I click on the button, it says public key cannot be invoked without a new. So यहाँ पे I have to write new public key of this. Here to have already written new public key. What is the thing? Instruction, send some money from here. This should ideally be my public key that BonkBot gave me. अभी जब मैंने random डाल दी, to भी मैंने random डाल दी, amount भी also I've chosen a random amount. Put that to the transaction. Try to serialize the transaction. Let's see if it works. lamp ports per soul is not defined. I hope you guys understand why I had to write this over here. Because when you are sending 0.001 Solana to a server, that is equivalent to you sending 10 raised per 6 lamp ports. 10 raised per 9 lamp ports is equal to 1 soul. तो अगर मुझे 0.0001 सोल भेजना है तो मैं यहाँ से 3 0 निकाल दूंगा. तो I can either write it like this or I can do a 0.01 into lamp ports per soul. And this I can import from @solana/web3.js. So I can just do the math over here. Now if I refresh, submit, buffer is not defined. Have we seen this before? Front end में when you try to use @solana/web3.js, it can run you into issues from time to time because it does not have the buffer class. अगर मैं यहाँ पे buffer लिखता हूँ नहीं चलता. If I write the same in a Node.js program, if I write node over here and type buffer, चलता है. So what do I have to do? This library was meant for the backend. If we use it on the front end, it was meant for the backend. So we have to bring in node polyfills to our project. Here is where the first hint might have helped you. कि अच्छा, there is a hint. I can add node polyfills. ये buffer class बना देगा. How do you do that? First, install it as a dependency. And then go to vite.config.js and add the node polyfills plugin over here. We have discussed this in the past. Import it and along with the React plugin, add the node polyfills plugin. इसके बाद buffer will exist in your website. You have polyfilled a bunch of things that exist on Node.js into your React project. Let me start it one more time. Now if I go here and try to send a transaction, it says transaction recent block hash required. Here is where you'll start to see problems in the serialize function. जो serialize function है ये ट्रांजैक्शन को अच्छे से इंस्पेक्ट करता है. इट वेरीफाइज कि ट्रांजैक्शन ऑब्जेक्ट शुड हैव एवरीथिंग. इफ यू रिमेंबर, we need to put the recent block hash in every transaction. If this is the Solana blockchain right now, every block has a hash, a random string that identifies this block. Whenever you create a new transaction, आप अपनी instructions तो यहाँ डालते ही हो. Along with this, you need to tell who is the fee payer. Fee कौन देगा specific transaction की? गैस कौन भरेगा इस ट्रांजैक्शन की? एंड यू हैव टू स्पेसिफाई द रीसेंट ब्लॉक हैश. कि भाई जो भी ये सारे ब्लॉक्स हैं, जो रीसेंट ब्लॉक है उसका हैश क्या था. सो यू हैव टू टॉक टू द ब्लॉकचेन, गेट बैक द रीसेंट ब्लॉक हैश, देन क्रिएट दिस ट्रांजैक्शन, देन दिस ट्रांजैक्शन इज व्हाट यू सेंड टू द ब्लॉकचेन. द प्रॉब्लम इज कि अभी हम सीरियलाइज कर रहे हैं ट्रांजैक्शन जिसमें ना तो ये है, neither this is there nor this is there. So tx.serialize is failing. Tx.serialize is telling you that you are trying to serialize a transaction but you haven't put the recent block hash there. So can we do that? Can we hit the blockchain, get the recent block hash and put it over here? How do you do that? We now have to connect to a RPC. We now have to connect to the blockchain and ask it for the recent block hash. So I have to create a new connection object. What does this do? Connects to the blockchain, connects to the RPC so that you can ask the blockchain for things. Specifically, we will ask for the latest block hash. कि जो latest block बना है अभी उसका hash क्या है? तो let me create a new connection. Where should this connection be to? I want to connect to the Solana blockchain. So what can I put over here? If you remember, we used a very famous RPC provider called Alchemy. I can use the Solana default RPCs as well, but it's a good idea to use them. They're a little more reliable. They will not rate limit you very quickly. So you can go to Alchemy or you can go to Helios. There are many, RPC providers, a good business. यहाँ पे जाके you can copy over, whatever. This is my first application. If I go to networks, I get my Solana RPC connection. I can also connect to World Chain. I can connect to Ethereum. I want to connect to the Solana blockchain right now. I create a new connection. And then before I serialize, I need to add the recent block hash there. Serialize करने से पहले I need to get the recent block hash, put it over here. So the way to do that is, thankfully, block hash is something that connection dot get latest block hash will return you. Up under the hood, this is a simple HTTP call. It is not like this is some complicated function. No, I can go to Postman and I can send the same request to this RPC. This RPC, I can send a random request. Let me get a old RPC request and replace this with get latest block hash. I don't need to send any parameters. That is exactly what the error is. And it returns me क्या latest block hash तो ये है. So just how I'm sending it via Postman, I can send it via HTTP using Axios, or I can use this very nice function connection.get latest block hash, जो मुझे block hash return कर देगा. As you can see, it returns me an object जिसमें दो चीजें हैं. I just want this part of the object, which is why I have deserialized the object over here or destructured the object over here. Then I can add transaction dot recent block hash is this thing. कि मैंने blockchain से मंगवा लिया. Since I sent an HTTP request, I need to await it. I need to update the recent block hash to be this. That's the first thing. ये हो गया. What is the second thing? Fee pair. Who's paying for this transaction? Let's say in this case we make the user pay. So can I write tx dot fee pair equal to ये same from public key. The person who's trying to send Solana is the person who will pay for the Solana. So let me write const from pub key equal to this thing. Let me define it as a global variable so I can reuse it. Here and here. I serialize the transaction, send the transaction to the backend. Hopefully this works. Let's see, does this throw any more errors? These are the two things I changed. Another error came. सब कुछ तो सही था. If you look at the network tab, it is sending a request to the RPC. It is asking for the latest block hash. It is getting back the latest block hash, which means this line of code is working correctly. और यहाँ पे तो हम सिर्फ assign कर रहे हैं. These two lines of code are also working correctly. There's an error here still. The problem is when you call serialize, it will verify क्या ये transaction sign हुई है. You are trying to serialize this transaction. Has it been signed by the user? And have we signed it? We don't even have the private key. How will we sign it? So if you look at the serialize function, it expects these two as an inputs. Require all signatures. We don't want that. Even though we just need one signature from one user, we don't want that. So require all signatures, we can set to false. If you don't, serialize will throw an error. Verify signatures. Do you want me to check जब मैं serialize कर रहा हूँ? Do you want me to check कि has this been signed? The answer is no. I don't want to require any signatures. I don't want to verify any signatures. both of them should be false. We get the serialized transaction. That is what we send to the backend. That is step 1. And now hopefully it works. Let's log it. Let's log the serialized transaction and see क्या log होता है. If I click on submit, look at the console, you will see a uint8 array is logged. This I can send to the backend. I can convert this to a string and send it also, or as it is I can send. The Node.js backend will be able to decode it as well. So now I have serialized the transaction on the front end. I am sending it to the backend. Backend needs to sign it, and backend needs to send it to the blockchain. Can we do a quick poll? This is the code that we have written. The send sol function. There are like a few things here, but do we understand this? For how fast I was, I think this is good. 85%. तो क्या बचा भाई? Backend request जा रही है. Go to the backend. This is the handler. Get the serialized transaction const serialized transaction equal to rec.body. What am I sending here? Message. Now we need to recreate the transaction object. यहां पे जो यूजर ने बनाया था, this whole tx object, we need to recreate it. And thankfully, the transaction class in Solana/web3.js lets you deserialize it. I don't know how. From transaction.from this uint8 array. तो ये जो serialized transaction जो array आया है हमारे पास, just pass it the from function. It will deserialize it and convert it back to this transaction object. You can't send a transaction class over the wire, but you can always serialize the transaction over here, deserialize the transaction over here, and what is left? Just signing it and sending, right? So tx.sign. Where is the user's private key? It's in the database. So यहाँ पे you will have to do something like const user equal to await, whatever, user model dot find where user ID is something, or whatever ID is something. You will have to write this logic. Then you will get a private key, something like this, and then you will sign this transaction using that private key. This is the ideal way to do it. I don't have the private key. Like, we don't have any database logic right now, but we do. We haven't tested it. So I'm going to comment this for now. I'm hoping it should be easy enough to add. नहीं तो मैं add कर दूंगा वैसे तो. I hope you understand what needs to happen here. Okay, when the user has logged in, they have a token. They will send you a token. You verify who the user is over here. You get their private key from the database, and then you sign the transaction using their private key. So let me just create a random private key. Not a random private key. मेरा जो wallet है ये वाला, this specific wallet, which has $2. This is what is sort of sending the transaction. इसी की public key मैंने front end पे डाली थी. तो इसकी private key I can sort of put over here, and then I'm good to go. So const key pair equal to new key pair. Here I should do whatever key pair dot from get that private key that should be passed over here, or whatever key pair dot from secret, and inside this I should pass the private key. Now we haven't written the database logic to put it, which is why I am initializing a random key pair for now. Ideally, this key pair should be with a private key for that specific wallet. बंदे का जो wallet है उसका key pair यहाँ आएगा. Then you sign this using the key pair, and then you send it to the blockchain. How can I interact with the blockchain? We have to create the connection object again. So यहाँ पे we can import connection class. I can create a new connection object. I can pass it the RPC URL. Same thing as here. And I can do a connection.send. Connection.send transaction tx. I should await it. That should do it. समझ आया? Hopefully I was simple enough. I don't know, you tell me. Did we understand the backend logic? Of course I've generated a random key pair over here. Ideally this should be the private key. Let me do that. Let me just export my private key from here. It has $2, so first come first serve, guys. No, I showed the wrong thing. I was supposed to show the private key. This is the private key. What do I want? I want to store the private key in a .env file. Should not have it in front of all of you. Private underscore key equal to this thing. Now let me go back here and add .env to my project. Oh, I stopped MongoDB, which is fine. npm install .env. This will install the .env package. What do you do next? You require .env over here, and then I will have the private key access that I've stored in the .env file for now. I shouldn't do this. This should be stored in the database for the wallet that the user has created. वहाँ उस private key से I should do it just to make sure I can show you कि चल रहा है. I'm doing a keypair.from and यहाँ पे I can pass the private underscore key. Only thing is this expects dot from secret. This expects a uint8 array. I am passing it a string. So if you remember, I was stuck at the same point last week. We found the solution on Stack Overflow or whatever, sorry, a gist. Here you can write this function. You can bring in the base 58 library because the private key is base 58 encoded. So let me do that. npm install base 58. While that is happening, let me import it here. And how can you convert a string private key that's in base 58 format into a bunch of bytes? You can call base 58.decode. So rather than passing the private key like this, I first need to decode the base 58 private key, pass that, something like this. We get the key pair object. We sign the transaction, send it over the wire. That should do it. Let's also log the transaction signature. Now my backend is actually signing that transaction on the behalf of the user. User की जो public key है उसी की private key से हम backend पे sign कर रहे हैं transaction को. If I start the backend, whatever node index.js, I have a small bug somewhere here. This should be an async function. Can't find .env. I installed it in probably the React project. Oh, I wrote don't env. It is .env. Mongo's issues, as I expected. I've done something wrong in MongoDB, like probably some argument attribute I'm using incorrectly. So I'm logging all the, commenting all the MongoDB logic, not importing any MongoDB logic here, just focusing on the transaction signature endpoint. Restart. The backend seems to be up. Let's go to the front end. Let's try to send it. Oh, front end is down. Let me restart the front end, refresh, send the transaction. It gets serialized, goes to the backend. Backend says not found. API v1 txn sign. What was our endpoint? API v1 txn sign. 404 not found. Who will help me out in chat? What am I missing? Can we chat? What am I missing, guys? If anyone was paying attention. Oh, chat isn't open. Oh, wrong port. Thank you guys. I appreciate it. Axios dot. Oh yeah, you're right. Thank you. Refresh it again. Send it. Failed with a different endpoint. Most probably the backend crashed from what I can tell. The backend did not crash. Oh, CORS error. How do I fix it? Stop the backend. Do a npm install CORS. Go to the top of the backend file. Do a const CORS equal to require CORS followed by app.use CORS. Simple enough. We have done this many times. Restart, refresh, send. Failed again. This time the backend crashed. Buffer is not iterable. Most probably this line of code, one of these two lines of code is failing. Sign, does it expect an array? It does. No, I think this is fine. That's fine. Node index.js. Let's restart, resend the application. Let's see where the error is. Before serialize पे सब सही है, यहाँ तक सब सही है, यहाँ पे fail कर जाता है. Let's see what serialized transaction we get from the front end. I've logged it over here. Let me send the request over again. I probably need to do a buffer.from over here. It's not a simple uint8 array. I can do a dot data and convert it into a uint8 array, or I can do a buffer.from over here. Given this buffer, given this object, convert it into a buffer. I think this should do it. Maybe not. We will see. But it's not. You're not getting a array. You're getting an object जिसमें कहीं जाके there is an array, which is why you have to convert it into a uint8 array. Refresh, resend. Again it crashed. Now it crashed someplace else. Base58.decode failed. Base58 is not a function. Decode. Most probably this is doing a default export. So ya to I have to write base58.default.decode, or I can just do this. I can destructure decode over here and use it directly. I think that should do it. If not, there's another way to fix it. Decode is not a function. Let's just log base58 as well. Most probably this is doing like an export of an object which has default over here. It's doing what's called a default export. There is another way to import it over here to fix it, or you can just, I'll log base58 and see what it returns and go from there. So I logged the bs58 library. I sent the response. If you look at the response, or default, my bad. Oh yeah, it is default over here. So base58.default.decode should be a function now. Now something else failed. Expected string process.env.private key. Okay, let me just make the private key completely public now. Paste it over here and try it again. Submit. Failed again. Invalid arguments to send transaction. तो लग रहा है कि सब कुछ हो गया. यहाँ पे it is failing. Transaction signers and options. I also have to give it a second argument. Who all has signed this transaction? In my case, first I've already signed it. I don't need to re-sign it. But let's just pass an array of signers over here, which in our case is going to be the user's key pair. Let's try it one more time. Submit. This time it's taking a long time here, which tells me that shayad it has reached the blockchain. The transaction is actually happening. We will see. I got a 4 to 9, which means I got rate limited. I don't know why I'm not sending too many requests. Let's try it one more time. I'm getting rate limited a little too much. Let me replace this with the default Solana api.mainnet-beta.solana.com. The default Solana RPC. Let's see, does that fix it? Submit. Transactions with block hash not found. I can re-get the block hash and fee pair over here. I would have expected it to already be in the serialized transaction, but maybe not. Either way, हमें यहाँ पे फिर से recent block hash डालना चाहिए. अगर user gave you some block hash and sent a transaction, it might reach you in a while. The recent block hash might change. So you should re-get the recent block hash here. Const block hash equal to await connection dot get latest block hash. The same thing we were doing on the front end. We do it on the back end. We reapply dot block hash equal to whatever. इस signature से पहले होना चाहिए. Here we get the block hash. We say transaction dot block hash is whatever the current latest block hash is. Transaction dot fee pair भी डाल देते हैं अभी के लिए. New public key. Or whatever, it can just be key pair dot public key. जो हमने की पेयर बनाया यूजर का उसकी पब्लिक की ही तो है फी पेयर फॉर दिस स्पेसिफिक ट्रांजैक्शन. So we can just do this. Then we sign, then we resend it. Let's see, does it work this time? Now I think the other RPC will also rate limit me. क्योंकि I'm sending more than one transaction. First getting the latest block hash, then sending the main transaction. But we'll see. Resubmit. Let's see what the backend says. तुमने मेरा अकाउंट खाली कर दिया किसी ने. Yup, good for you, whoever did that. But someone sweeped my Solana. I will come for you, whoever you are. 5B, 9:59 PM. वापस भेज दो यार. We will be able to see if it's working or not. Else I'll have to pull out my ledger. But whoever you are, I will find you. I will congratulate you. I think that is good. It wasn't a lot of money. It was like less than $1, I think. And you left the USDC in there, you dumbo. Like majority of the money was in USDC. You can't pull out USDC until you have to put back Solana in there for gas. And I will be running a sweeper. So when you do that, I'll pull out your Solana. So this wallet is sort of stuck right now. It has some USDC, but has no Solana. So everyone has its private key. You have it, I have it, everyone has it. Whoever wants to pull out this USDC will first have to put some Solana in there. As soon as you put some Solana in there, I will sweep that Solana, or some other guy will sweep that Solana. So this wallet is sort of in a hung state now. This USDC should ideally always remain there. That is why you might see comments on my videos very commonly that say, "Hey, I lost my wallet. Here is my seed phrase." वो आपका seed phrase दे देंगे. आप Phantom में डालोगे, you will see there's $1,000 here in USDC, but no Ethereum. Same thing has happened in this wallet. There is some USDC, but no Solana. Whoever wants to pull out this USDC now needs to first put in some Solana. But if they put in some Solana, everyone has the private key. The other person will immediately pull out their Solana. So now this USDC considered to be gone forever. Even though अभी तक तुम में से किसी ने no one is running a swiper on this right now, sniper on this right now. So if I was you, I would quickly send some Solana, pull out the USDC, pull out the Solana, and sleep well at night. Okay, I've made $2 tonight, and otherwise this will remain stuck. But long story short, I saw the error over here. The error said no attempt to debit an account found no prior credit. Basically means आपके पास Solana 0 है. Whenever you have 0 Solana, you see this error. So whoever pulled out the Solana, please send it back जल्दी से. Whoever you are, and then I will complete the class and then we'll call it. नहीं भेजोगे? I don't have a different wallet which has Sol right now, unfortunately. Yeah, I don't. But ठीक है, happy to just push the code. You guys can take it from there. Hopefully it's clear. Let me push the code first. Let me hide the private key. Right, the code has been pushed. Did you guys understand all that I did? We did it for one instruction, but you can literally do it for any instruction. आप यहाँ पे system program dot transfer की जगह you can call token program dot transfer. You can call metaplex dot mint NFT. You can call metaplex dot transfer NFT. You can call radium dot swap Solana for Ethereum. So you can put any instruction over here. We have put one instruction, but for an application like BonkBot, you just need to support 3-4 instructions. So you can put all of this logic directly on the backend. इतनी मेहनत करने की ज़रूरत ही नहीं है. You're serializing transactions here, sending to the backend. Backend is deserializing transactions. You can do it, but easy way is to just do it directly on the backend. Frontend will only tell you what type of event it wants to do. I want to do transfer to this address for this much amount. Backend will handle everything. Why is this approach better? Because user can literally put any transaction in there. Most transactions ke to, it's easy to find these SDKs or whatever, libraries जो instruction बना देती हैं. Some might be a very complicated contract you have written. तो उसके लिए कैसे बनाओगे? तो for that reason, if you want to support arbitrary transactions, then you use this approach. If you want to support specific transactions, token transfer, native Solana transfer, meme coin buying, then you don't have to do all of this on the front end. It can directly happen on the back end. But that's all I had. Let's do a quick poll. How was the class? And then I'll answer questions from Q&A. Great, we understood everything. 95% is beautiful. Any questions? Pause chat. Let's see. Google Doc, Notion Doc, .n.config. That's probably it. You're right. Oh, too many Notion docs. Sniper bot, please. What do you want me to write it or what? Actually, writing a sniper, it's easy to write it. It's hard to make sure you are the one who's running it faster than everyone else. Let me show you. Oh, my phone is dead. I had this. My YouTube video always gets these. Every Web3 video will get a comment. Great video. Hey, sorry, by the way, I have some funds in my wallet. I can't recover it. And they'll put their seed phrase there. So it always feels like, you won a jackpot, but yeah, someone else will come. Sorry. Someone else will come and, snipe your Solana before you can pull out their USDC. Or usually this happens on Ethereum. So snipe your Ethereum before you can pull out USDC. Increase classes, I can only try. But if we do increase them, they'll be like recorded classes, not live classes. All right, a bunch of Notion docs that I'm going to answer, then we'll call it alrighty. Tailwind plus Web3. I'm Parth. I recently worked on a project. Deployed link is here, submitted for the hackathon as well, but the UI was very basic until now. Some more good. Use pre-built components over here. Try connecting wallet and seeing transactions in DevNet. All right, let's see. It looks pretty good. Do I have to sign a transaction? Send now. Is it, what is this like a, what does it do? Does nothing. Shows me my Solana balance. That too I think is incorrect. Yeah, and my public key, and lets me send. Why would I not send directly from Phantom? Why would I ever come to your website? I don't get it. What does it do? None of the buttons work. I have no idea what this does. Smart contract save. If the wallet system interacts with a smart contract, consider implementing withdrawal limits, multi-sig smart contracts that require consensus amongst trusted entities. Yeah, that's a really good point. The wallet system that interacts with this, yeah. So multi-sig is almost like that, and also, so one thing, no one uses smart contracts for wealth management or whatever, private key management. Everyone has a private key stored with them. This is a very fancy idea that we also thought of. Okay, on Ethereum, we'll create our own smart contract where we'll store who has how much money. It'll be very easy for users to verify we actually have their funds, yada yada. Never happened. Most exchanges, gambling websites, whoever is taking crypto from you, don't store it in smart contracts. There are multiple reasons for it. One is interacting with a smart contract always involves some gas fees, versus if you're pushing everything to a wallet, to a fat wallet, then the number of transactions that you have to do on chain get minimized. That said, this is the one thing that I see here that's really good is withdrawal limits. If you do fucking get hacked, 10% of your funds go away, not 100%. So that is good, but what a lot of exchanges are thinking of doing right now is splitting their funds anyways into 6-7 different fat wallets, so that if one gets hacked, they don't lose all their funds. So yeah, long story short, it's that threshold access control. What is that? Outsourcing parties or decentralized nodes. Yeah, the more decentralized you make it, the slower the process becomes. Like, this is sufficiently decentralized if you have 26 guardians, like Wormhole does, or even in exchange, 5 different cloud providers. Uske baad bhi, if you get hacked, like, there's no reason for a hack, unless of course your MPC cluster gets hacked, which there's a very low probability. In Japan, there's a different DevOps team that handles the Japan AWS MPC. There's a different team in US which handles a different one. So it's very hard for them to communicate and create a process like this. In this case, only the employees can do anything, unless your security is so bad that people are able to hack all 5 of your cloud providers. Most probably the thing that you're protecting against is employees or CEO, whoever, people who have access to the MPC cluster. So yes, that is a problem, but that can mitigate with the public key approach that I talked about. So uske baad, it becomes sort of an overkill to try to decentralize this further, and that just becomes I wouldn't call it a headache, but the thing is, the centralized exchanges can't decentralize. This might be true for BonkBot; they can probably do it, but for centralized exchanges, they need to have control of the servers. If a government asks them anything, they need to have the servers at their disposal. So might not work there, but this is like good. I don't know what threshold access control is. I would assume it means you can only pull out XYZ amount in a day. Strict role-based control, access control. Like, I've heard about this in Web2 systems. I've never heard of an RBAC in a Web3 system. Is there one, or is this just something you're suggesting? But yeah, smart contracts safeguards would make sense if people who are holding funds ever created smart contracts. They don't right now. I'm trying to build a Telegram bot for launching an NFT, but when I try to create a liquidity pool through Node.js, I can't find a repo or doc. With the SDK, I can't figure out. For creating a liquidity pool, I've done it. Let's see, Radium Docs API SDK JS. CL pool, do you want to create like a AMM, or do you want to create, there you go, AMM pools. Let's say you want to create an AMM, not want to get too fancy. So, this is the API. Question is, how do you create a pool? Pool creation fees, creating a constant product, this thing. I'm sure they have an SDK, wait. Create source pool create index utils. There you go. Create pool instruction simple address. They have a function called make mock hai. So never mind. This is probably something for testing. Make available. make increased liquidity is there, decreased liquidity is there, make swap instruction is there, make a pool क्यों नहीं है? Make init reward instruction simple, make set reward instruction simple, make set reward instruction simple, make collect reward. बेस क्या है इसमें? base from /base. So let's go to there. Whatever base.ts probably has the base class. There you go. Create pool. Let's search for that. There you go. Create pool instruction. This is what I was looking for. It takes the pool program ID of most probably what kind of AMM you're trying, liquidity pool you're trying to create. Every pool probably has a different program ID, or might be the program ID of these guys. इनके program की program ID होगी. Pool ID. This probably you'll have to derive. The thing about Solana is whatever you're interacting with, you have to send it up front. This probably will be a PDA. Pool creator will probably be yourself. Whenever you're creating a pool, you first send an instruction to create a config, like an AMM config. ये उसकी आईडी है जो आपने AMM config बनाई है. What is the ID of it? Mint A, mint vault A, mint B, mint vault B. This will be the mint address of the tokens. This will probably be some PDAs that you've derived from it. You will call this function to create a pool on whatever. Or this function might be called by some higher level function. That will make it a little bit easier for you to send the inputs. It will probably figure out the PDAs itself. But let's see. Create pool instruction. This one probably looks easier. Yeah, this one looks easier, right? Make create pool instruction. Simple enough. Under the hood, this will probably be called calling the other function. But yes, if you look at it, this function is called make create pool instruction. Takes the connection as the input, the program ID. This you'll have to figure out. Most probably will be the V2, V3 program ID of Jupiter. Owner will be yourself. Mint A will be, let's say, USDC. Mint B will be, let's say, whatever, Bonk. AMM config ID, the thing that I talked about. Before you create a pool, you have to create a config. Initial price x64. It will probably be, what do you think is the initial price? जब पहला बंदा liquidity डालेगा वो किस proportion में डालेगा? And then the start time, when does the pool start? This is the instruction का function. So import this Radium SDK, call make create pool instructions. इससे पहले call create AMM config function, and then go from there. उसके बाद आपका pool बन जाएगा. Here only you will find add liquidity, remove liquidity, things like these. You can use those functions, go from there. Great, that is done. What is the other? Notion docs allows users to earn interest on deposit or borrow against collateral or something. You can do that. People provide liquidity against NFTs. There's this platform called Sharky something on Solana that you can use. Shark.xyz, Sharky.xyz, something like that. You can put your NFT, get some SOL. If you, there's like some 7% interest. If you return in 7 days, great. If you don't return, you lose the NFT. So what's the question again? Where should I begin? Oh, you want to build something like this, I would assume. Yeah, it's simple. I mean, it's not simple enough right now if you have not written smart contracts. But long story short, आपको एक smart contract लिखना है. There should be a function inside. Whenever the user calls a function there, you have to send their NFT to you and whatever, revoke some Solana from you. If they return it to you in 7 days, great. If not, you'll keep their NFT, and there'll probably be another function called redeem for admins that admins call from time to time to take those NFTs and sell it on an open market so that they're not holding the NFT back. अगर 7 दिन में आपने नहीं लौटाए पैसे, they'll probably immediately sell your NFT. Actually, what happens is people get your NFTs. Yeah, that's where, what is that other platform called? Ethereum. Ethereum, maybe there was this platform where you could loan your Bored Apes. A lot of people did it. And then there's a spiral loop that happens. If one guy sells, two guys sells, price crashes. That leads to more of the loans defaulting, and price, more sell pressure, then falls even further. So yeah, basically not too difficult to build. and on Ethereum, it should be fairly straightforward only. Okay, you transfer an NFT, get back some Ethereum. If you don't return the Ethereum, people can take your NFT for a much lesser price after the 7th day, let's say. So people actually start bidding in the last 1 hour कि मैं इसके इतने दूंगा, मैं इसके इतने दूंगा, and then whoever is the highest bid for your NFT जिसके लिए आपने लोन लिया था, that person takes the NFT. So will I be, yeah, so for backend, if you're doing it in Solana, you have to do it in Rust. You don't need to be, yeah, you need to be decent in Rust. You will always chat GPT it, it'll give you something, but I would urge you to learn Rust. Learn how smart contracts, what they expect as inputs. It's a little weird in Solana. Then you can, yes, create it. That would be my advice. Is there any path to create DeFi? Create this DeFi. Oh, is there any path? There are contracts. Most companies have these contracts open so that users that are interacting with it can trust it. So you can look at their program, but most probably won't understand. Probably create a simpler program that takes an NFT from a user. Then create another program that gives them SOL. Then combine them to take an NFT, send them SOL in the same transaction. Then create another function that the user can call to return the funds. If they are returning the funds plus some interest, then you return their NFT in that transaction. Then they create a third function called battle or redeem or take away. Where other users can come, bid some amount for this person's NFT, and if after 7 days that person does not return the collateral, then this other person who has the highest bid can come and redeem the NFT. So something like that. There will be like 4-5 functions here. You need to know Rust though. Solidity mein likh lo, pehle it will be easier. Oh boy. Inheritance is the idea in a nutshell. That is a good idea. First time I'm hearing it. It's a very unique idea. How do you prove someone's dead? Oh, he's writing. No, that's fine. How do you prove someone's dead? Oh, that's pretty good. That's pretty good. That's pretty good. I've never heard of it. The thing is, yeah, you should apply for a grant in Super Team. This deserves a bounce. So I had a similar idea. Think about it. It was time locking a video. I'll shoot a video. Problem is people look at their photos, delete them, lose their phones. I can use your smart contract there. Yeah, but like, how do you encrypt video? The problem is no one should be able to see that video for 5 years. And after 5 years, it should automatically get decrypted. Is it a Web2 thing though? I don't know. Only I with my private key should be able to decrypt it. Sure though. But it's a good idea. Like yours is also a great idea. Mine is one I've been thinking for years. I wanted to call it Time Capsule. There's a movie I saw this mess out there. But can we save the videos on? No, yeah, you sort of can. IPFS you can store it. But it really doesn't matter where it's stored. Because everyone can download it. It's on chain. Question is how is it encrypted and how can you ensure it can only be decrypted by after a year? So there is something called time lock puzzles, if you have heard of them, that can be used here. Time lock puzzles say, okay, you encrypt something and it's very difficult to decrypt it. There is an algorithm that needs to run for at least a year and only then you will be able to decrypt it. Encrypting it you can do in like 10 minutes, but decrypting you need a year then. Of course, if machines get more and more this thing, smarter over time or faster over time, then the time goes down. But yeah, sorry, I've been talking too much. Yeah, you're right. Let's look at it. Can you show the smart contract also? Beneficiary address. All right. I had $2. I should have put them here. connect. All right. Copy. I don't have one soul to give. Also, why do you need one soul? Just show me the contract. I'm happy to use it also. Question is, where is that? Sorry, what do I have to do so that it knows I'm alive? I have to keep interacting with the contract once a year. Oh, acha, DevNet only. Got it. Settings. कहाँ होता है इनका preferences? Don't have any soul here. .2 soul here, 0.7 soul here. Like 0.99 soul here. Let's see, does it work? Okay, the beneficiary is going to be account 3. Let's say 10 minutes for now. Create custom timer. 8x0. Oh, there we go. Create custom timer for 10 minutes. All right, done. One soul. Okay. Oh, I have to check in every. Okay, makes sense. This is very cool. Very great, like very good UX. Oh, so one soul is logged now. One soul is inherited. Here's the problem with this. The problem is, while I'm alive, I also want to use my 100 soul, 1000 soul, whatever I have, right? You've sort of taken them away from me and logged them somewhere. But if you are dead, then you can't approve the wallet. So what is the middle ground here, sir? That's what I'm asking you. Is there something else you can do? That isn't necessary. How can I keep using it? But if I die, someone else can use it. No. I will still check in with you. But my funds, I also want to use while I am alive. And when I die, and I don't interact for a year, you should be able to pull my funds out. Okay, read about delegation. You can delegate tokens. And as the name suggests, if you delegate a token, they can use it also. You can use the token also. And if you die, they should use the token and pull them out to your family's address. But while you're alive, you'll keep using it. So read about it. Token delegation, very commonly used. For example, if I have an NFT and I want ऐसा होता है कि समटाइम्स यू हैव एन एनएफटी, दे मेक यू प्ले अ गेम कि एनएफ अगर आपके पास एनएफटी और पे गेम खेलोगे आपको कुछ मिलेगा. तो यू नो people delegate their NFT to a gamer in Thailand. He plays on their behalf. So like token delegation, Solana has it. It's very simple. So yeah, add that rather than having this, because if my net worth is unlocked somewhere, it's very sad for me, right? I can't even pull it out. So yeah, but this is a pretty good idea, by the way. So yeah, kudos to you. All right, cool guys. We'll call it here. It's 10:30 already. Have a good night. I'll see you guys tomorrow in the web dev cohort. Let me take a few more questions. Yeah, we're starting TypeScript tomorrow. Are you going to? Why not? Yeah, LST's Bali video wasn't